Thanks for coming. My name is Pete. I'm the Computer Systems Administrator here at AOS. I actually got my degree in meteorology in 1988. I'm guessing that's before you were all born, which is terrifying. Got my master's in atmospheric science in 1992. I did work with Greg Tripoli, who just retired a couple of years ago, and we did computer modeling of mesoscale phenomena like gravity waves and thunderstorms and polar lows and other small scale features like that, doing a lot, trying to understand how the smaller scale convective stuff interacted with the larger scale circulations of things. And while I was doing that, I sort of managed his group's computers, and over time I sort of got to know the AOS computers, and I got hired to do this job in 1995. So I've been doing this a long time. I've been working with Unix pretty much since then, and I give this talk every year just to try to demystify it, since a lot of the work that we do here, both in like 452, 453, a lot of the classes, and a lot of the research the graduate students do is using computers that run Linux, which is, it's an operating system, but it's not like Windows, so it's a little bit confusing if you're not haven't kind of had an intro of it. And I go over a lot of stuff. I go over it pretty fast. I don't expect you to necessarily remember everything that I'm going to go over tonight, but you've got the handouts for reference, and hopefully sometime down the road when you're doing something, and you'll be like, oh yeah, I remember Pete said something about that. That's sort of what this is, just to kind of familiarize yourself with it. So, actually, we're taking this thing, I can flip through the slides without having to do it. Okay, so that's me, that's my contact info. If you're in the building and I'm here, you're welcome to stop by if you have a question or any problems. I'm happy to answer them in person or take a look at any problems that you have that's going on. So real quick, the computers that are in here, they're dual boot Windows or CentOS version 7 Linux computers. They're mostly all the time running Linux. So if you logged in, that's running Linux, so that's not Windows. I encourage people, if you're in here, I know a lot of people usually are running on their own laptops, but these are here for your use as well. Please log off when you're done and reboot them. They're set to automatically reboot into Linux. If you just log out or if you just restart them, they should come back up in Linux. So the general idea is that when you walk in here, all of the computers are running Linux. I'll show you how to flip them into Windows if you want to run Windows, and then how to go back to Linux. There's 15 machines in here. There are 4 identical machines in room 1443, which is the conference room right next to my office. I'm in room 1447. So if you want to use one of these computers and there's a class in here or whatever, there's additional computers down the hall. There's also the Jupyter Hub server. If you've done any work in any of our classes on that, it uses the same login information, and your home directory is the same there as it is in here. So you've seen the Linux login screen. To switch from Linux to Windows, click in the upper right-hand corner right there. There's like a power thing. You can reboot it. When it comes up, you'll see something that looks like this. This is called the Grub boot screen. This is what allows you to boot into either Windows or Linux. And there will be a number of lines at the top that will talk about Linux, and then one at the bottom. I couldn't find a good graphic that actually used Windows 10, so it says Windows 7. That's actually better. Before today, it said Windows XP, which goes back a while. That's old. But anyways, the bottom line should say Windows 10 or Windows Boot or something along those lines. To get into Windows, at this screen, use the down arrow keys to get the bottommost line on there, whatever it happens to be, and it should boot into Windows. There is a guest username. The username is AOS, and I wrote the password down on the handouts that I gave you. I'm not going to put it on the board because I don't want everyone knowing it. The AOS account works on both Windows and Linux in here, so if you need to access either Windows or Linux and you don't have an account in here, you can use that AOS account. There's only an AOS account on Windows, and the AOS account on both Windows and Linux is specific to that machine. It doesn't, if you log in and do anything on one of the machines using the AOS account, you have to go back to that same machine to access it later. That is not the case if you have a real account in here for Linux. Excuse me. I usually set up accounts in here using your NetID as a username and then something different as a password. So if you log in with a real account like that with your NetID, it doesn't matter which of these machines you log into. Your home directory is on a server somewhere and it's always the same on any of them. So it doesn't matter which machine you log into. If you save anything one day and you come back and you're on a different machine, you'll still be able to access that same stuff if you're logged in as with your username instead of the AOS account. So, some of the software that's available on Windows, obviously Microsoft Office, so like Word, Excel, PowerPoint, all that stuff. Most of them have OpenOffice on them, or LibreOffice, which is an open source version of Microsoft Office. If somebody sends you a document and it's in that format, Microsoft Word probably won't be able to open it, so you can open it using OpenOffice or LibreOffice in here. The Adobe set of tools are on most of the machines in here also. I think you have to log in to those using your NetID and password for like your email account, which is different than the password that I use for the machines in here. And I think it times out every half an hour for the lab versions of that, so you might have to re-authenticate every so often. Web browsers, there's a program called EdGCM, which is a global climate model that you can actually run on these computers and do climate simulations. Some of our classes use that. Hydra, I think, is a radiative transfer model, and a bunch of other stuff depending on what class you might be using these for. I'm not going to spend a lot of time on Windows because sort of everybody knows how to use it. To get back into Linux, you want to reboot, which is just hit the start menu. Of course, this is again a Windows 7 reboot thing, but you basically go in to the start menu, reboot, and use the up arrow to go to the very top Linux kernel. There's going to be a number of them on there, and they do that. They keep older versions of Linux on there. The kernel is like the main part of the operating system. When you upgrade the kernel, there's a small chance something could go wrong and it won't boot. The old kernels are left on there so that if that does happen, you can boot into one of the older kernels and try to fix it, try to figure out what's going on. But generally, the graphics drivers for these machines are specific to the version of the kernel that you're running. So only the topmost one is going to work with the graphics. If you bring it up in one of the other ones, it's probably going to only work in a text mode, which is most of what we'll be talking about today, how to do things in the command line. So once you get back in, you can log in using either AOS or your username and password. Like I said, if you use your own username and password, it doesn't matter which machine you log into. Your home directory is on a server down the hall, and it'll be the same no matter what machine you log into. Those are all the machines in here. The 4 machines in 1443 and the machines in the front of this room and 811 and 823 are all set up basically the same way. So when you log in, you'll see something that looks like this. It's a desktop. It looks sort of like Windows, but not really. The start menu is sort of up in the upper left-hand corner along the top bar there. There's a bunch of applications. If you install Linux on your own computer, there's a lot of stuff that comes with it for free. Different, like Gim was talking about, like a image editing program. There's LibreOffice usually comes with it for word processing and spreadsheets and stuff like that. There's tons of software that comes with it for free. And a lot of that stuff is available through this applications menu on the left. Here's just an example. One of the things is the terminal, which is what you use to do a lot of the stuff we're going to be talking about for the rest of tonight, that command line. You can access that either through the applications menu, system tools, and terminal, or you can access it, I think, if you right-click in the background of the desktop and click Open Terminal, it'll do the same thing. The difference is if you do that, it's going to open it starting not in your home directory, but in a desktop folder in your home directory. Whereas if you open it this way, it will actually start in your home directory. That can be a little confusing if you open it the wrong way and stuff that you saved isn't where you thought it was. Let's see, the system menu, I think, this is actually, old. This looks like an older version of Linux. I think on these, sorry, no, that's the same. That is right. So it should be up here if you wanted to restart it, system shut down or log off. So that is the same as what I've got on there, which is good. So when you're done, you can log out from there, or if you need to reboot it, you can use the shutdown option, which gives you an option to either shut down or restart if you want to get to Windows. By the way, there's only 2 of you here, so stop me if something doesn't make sense, right? This is like a question and answer. I'm going to go through my spiel, but if you have a question or something doesn't make sense, I go too fast, let me know. Just stop me. So this is what I'm going to talk about tonight. This is the intro to Unix part. Operating systems, that's like 2 seconds, and history of Unix. I spend a fair amount of time on the basics of a Unix session and the Unix file system because that can be pretty confusing to people, and once you start to figure it out, a lot of things make a little more sense. Working with files and directories is a pretty good chunk of it. Talking about your environment, a bunch of common commands that are on all Unix or Linux systems that you might want to use. Compilers in terms of compiling computer code, email, text processing, image processing, and at the very end, VI editor or VIM if you have an interest in that. So that's where we're going tonight. So the operating system is the program on the computer that controls everything else about the computer, right? You're probably familiar with Windows or Mac OS. Linux is another one. Unix was actually originally written, but Unix is actually proprietary. You actually have to buy it. And a while ago, this guy named Linus Torvalds, I forget where he's from, Scandinavia somewhere, wrote an open source clone of it and gave it away for free. And it's become this huge thing, like almost every cloud service that you'd ever hear of runs Linux. It's crazy and it's free. Other, iOS or Android for phones or other operating systems, that's the kind of thing we're talking about tonight for Unix. It's been around a long time. This guy originally wrote it, these guys. It's been around forever. There's sort of 2 main kinds of Unix that are out there, 2 main flavors. One of them is this Berkeley Unix, BSD, which is actually the version of Unix that lives underneath Mac OS. If you're running Mac OS, it's actually running a version of Unix under the hood, and it's that BSD Unix. And at some point, there was a fork of it that was slightly different. AT&T got a hold of it, and that's called System 5. So those are sort of the 2 main flavors, and the big difference, they both do a lot of the same things, but the options for a lot of the commands are slightly different, and sometimes the output that you get from the commands will be different depending on which one you're on. That's sort of what I talked about there. There's just some versions of Unix that are one or the other, like Solaris, which runs on Sun operating systems, SGI, these are all versions of Linux, kind of on older machines, now that I think about it. And BSD, Linux, I think originally was sort of based on the BSD version, but Linux tends to have a lot of sort of blend between the 2, like a lot of the options sort of work. Either the BSD or the System 5 ones work either way on Linux. So Linux itself is just the kernel. That's just like the main program that runs all of the different pieces of, talks to the hardware, it talks to the disks, it talks to the monitors. To actually make an operating system, you need other programs that go along with that, and that's where you get into Linux distributions, where they'll take a Linux kernel and a whole bunch of open source other pieces of software, put them all together and package it and make it available that way. So that's Linux distributions. There are 2 sort of main versions that I'm aware of and that I typically run into. Some of them are RPM based, that's a Red Hat package management. So Red Hat is a company that created a software, a distribution of Linux and sold basically, they gave away the source code and sold support for the operating system. They still do. Because they give away the source code, because it's all open source, they have to make the source code available. Other people can grab that and recompile it from the source and make their own versions of Red Hat operating system without having to buy it. There were a whole bunch of them a while ago. CentOS is the one that we run in here. It's the Community Enterprise Operating System is what that stands for. And it's basically a recompile of Red Hat Enterprise Linux. At some point, Red Hat decided that they were not going to, they bought CentOS from the people that originally created it, and then they changed their minds and said, well, we're not going to do that anymore, we're going to make it be our development version, so it's not the same as Red Hat anymore, and it's not supported as long as Red Hat or CentOS used to be. And the people that originally wrote CentOS said, that's a bummer, we really want to have an open source version, so they created this Rocky Linux, which is named after one of the original developers of CentOS who died of cancer. He was involved in a lot of the early CentOS stuff, and he died before it actually became big, so they kind of honored him that way. So the version of Linux that we're running in here is CentOS version 7. That goes end of life next summer, and I'll be upgrading all of this stuff to either Rocky Linux version 8 or version 9, because Rocky Linux is actually supported for about 10 years after it's released. The other main type of distribution is something called package-based. It's just the way that their code is packaged and the way that they deal with dependencies and stuff. Debian is sort of the main one. There's a fork of that that's called Ubuntu. You may have heard of Ubuntu. A lot of people run that on their laptops or in general. I typically run Rocky in here because it's supported for a really long time. You don't have to update it all the time. Or you update the software, but you don't have to reinstall and upgrade versions all the time, whereas with Ubuntu and Debian, a lot of times they're supported for 2 or 3 years, and then you've got to do a new version, which is kind of a hassle. It's nice because I think it tends to be a little farther ahead of the curve in terms of newer hardware, so like, with a laptop that has new chipsets and things, things tend to work a little bit better with the Debian or Ubuntu-based Linuxes. So if you've got a laptop and you want to put Linux on, I would probably recommend Ubuntu. But in here, I typically run RPM, CentOS, or Rocky-based stuff. Especially for, like, a lot of the professors have servers that they'll buy and they'll run them for 5, 10, 15. I think one of our professors had a computer that was running like 20-some years before I finally told him, look, you got to get rid of this. But anyways, that's nice because I can just keep updating it without having to completely wipe it and reinstall a new version of the operating system and so on. So, history of Unix, it's been around a long time. It was written by computer programmers for computer programmers originally, which is why a lot of the commands are abbreviations, because if you're a computer programmer, you're typing all the time, and the less you have to type, the better. At least that's why I think it's all abbreviations. So all of the commands in Unix are case sensitive. They're almost entirely lowercase, but not always, but most of them are, and they're almost all abbreviations. So we'll talk about that in a little bit. Any questions about that so far? It's a little break quick. Okay, so the shell. When you first log in to Unix on the command line, so when you open a terminal on one of these machines, the command line interface where you do stuff is called the shell. And some common shells that you'll run into, the original 2 that were first written with Unix were the Bourne shell, which is usually abbreviated SH, or the C shell, which is abbreviated CSH, and that tends to have a little bit more C programming language-like syntax to it. People wrote newer versions of those that had additional features, because the original ones are pretty cryptic. The TC shell is sort of an add-on or an enhanced version of the C shell. It has the same syntax but a lot more features. The Born Again shell is like the Bourne shell, but again has additional features. So a lot of times, those are the ones that you'll typically see on Unix or Linux machines. That'll be TC shell or the bash shell. In this lab, if you log in using an account in here, you're probably going to be using the TC shell. For historical reasons, I've got a lot of stuff set up that works well with the TC shell. Unfortunately, we're moving towards Python, and Python tends to work better in bash. But you can run a bash shell just by typing bash at the command line and then start a bash shell. That works well too. So at some point, I'll probably change my philosophy and just set everybody up in here with bash and figure out how to get the things that I currently have working under TC shell working under bash instead. I just haven't had a chance to do that. A couple others that you may run into. K-shell is another one that a lot of people like. It's, again, similar to the Bourne shell, but it has a lot of cute little programming tricks that you can use to make things set it up in a way that you're comfortable with, I guess, is you can make it work for you, if that makes sense. And then Z shell is another one that's also kind of similar to Bash and the Bourne shell. For a long time, Mac OS used Bash for its shell, and when you would open a terminal window. About 2 or 3 operating systems ago in Mac OS, they switched that, and now the default shell is ZSH. And the syntax is very similar. If you know how to use Bash, you know how to use ZSH. There's just some other features that are in it. And I think part of the problem was Bash, I think, is a proprietary. There was some reason why Mac OS got stuck on an old version of Bash, and due to licensing, they couldn't upgrade it. And I think that's why they switched to ZSH, because now they can keep updating it, because that doesn't have that issue. It's distributed under a different license. Okay, so things that the shell does, you can create an environment that meets your needs. You can change how things happen or how things work. You can write shell scripts, which are basically batch files. In other words, a file that has a bunch of commands in it, that you type one command and it does a whole bunch of things. Those are typically used in our environment for like Jetpack programming scripts, and I'll talk a little bit about that later. You can define command aliases, so if you find yourself typing a really, really long command over and over again, you can sort of roll your own command that does that. So you like type 3 characters instead of 50. And I'll show you how to do that later. It does keep a history of commands that you've already typed, and you can go back and manipulate those, so you can go back and rerun them or edit them. So if you have a command and you want to rerun it with a different file name or something, it's really easy to do that, rather than having to retype the whole command. All of the modern shells have command completion or automatic completion. So if you type something, whether it's a command name or a file name, and it's unique, you can hit the tab character or the tab key, and it'll automatically complete what it should be if it's unique. And then you can edit the command line. Like when you go through the history, you can bring up a previous command and easily edit it without having to retype the whole thing. So those are basically the things that the shell does. Logging in, of course, when you log in here, you've got a graphical login and password. If you log in remotely, you're going to get a login prompt. Possibly you type in your username, and you type in your password. This is where I have to give the password speech, because it's important to have a semi-complicated password. You don't want something that's like a word in a dictionary. You don't want something that has like your personal information, like your address or your last name or whatever, because it's pretty easy to guess. This is actually becoming a little obsolete because computers are getting so fast. It would be pretty easy to run a brute force attack on something like that over a weekend. You know, run 500 million passwords or however many that is. But anyways, multi-factor is a way around that, where it's something that you know, like your password, and something that you have, like your phone, or like when you use Duo to log into UW. If somebody steals your password, if they don't have your phone, they still can't log in. But it's still important to have a complicated password so that people can't access our systems through your passwords. It's a good idea. Choose a phrase that you're going to remember. You've probably heard this before. Choose a phrase you're going to remember, and choose like the first letter of every word, capitalize some, change some into special symbols, or have a phrase, like a really long phrase that you can remember that it's kind of hard to guess. Like, I hate having to change my password every 3 weeks is a 50-character passphrase that, maybe if, you can remember that, but it's kind of hard to just guess, right? So there is a do it page that talks about passwords, how to choose good passwords. I encourage you to look at that. You might think, well, what do I care? If somebody gets in my account, what I've got weather data, who cares? But the problem is, if they get into our systems, we're on a pretty high-speed network, and if you were going to go breaking into like Defense Department computers, you're probably not going to just try to connect from home, because 10 minutes later, the men in black are going to be at your front door like, hey, what are you doing? But if you break into one of my systems, and then from here you break into UCLA, and then from there you break into Minnesota, and then you break into Miami, like 10 computers later, then you go into the DOD. Well, in the DOD, then the men in black show up at Miami, and then they gotta go to UCLA, and by the time they get back here, maybe the logs are gone, right? So the hackers are usually interested more in our resources than necessarily what you have on your computer. And it's also an end to get at other campus information, you know, social security numbers or financial information or whatever. So anyways, it's a good idea to have a strong password so that people can't get it. That's the password speech. I gotta give it. So on Unix, it is possible to log into a machine more than once. And in fact, many people can be all logged into the same machine at the same time. That's similar to Mac OS now because it's obviously sitting on top of Unix. Windows, I think you can do the same thing. But that's something about Unix. Yeah, many people can be logged in. There is a way to remotely log into Unix machines if that's set up. All of these machines right now are set up so you can remotely log into them. You have to be on a campus network to access them though, or use the WISC VPN software. You guys both know what that is? Okay, so if you're off campus, you need to be connected to WISC VPN, to SSH and any of our systems. If you're on campus, you don't necessarily have to, like for the libraries or union or whatever. I think that stuff is all on campus already. I generally in the past have recommended don't remotely log into these computers because they are dual boot and you might be in the middle of doing something and somebody's going to reboot it into Windows and then you lose whatever you're working on. For that reason, I have 3 remote access machines. They're actually not in this room, they're in a closet, basically. But they're basically the same as logging in remotely to any of these machines. They're named Cat3, Cat4, or Cat5.AOS.WISC.edu. So when you SSH, it would just be Cat3.AOS.WISC.edu. Those machines are always only ever running Linux. So if you want to log in and do stuff remotely, you can log into these. I think the TAs have been encouraging people to because we don't use them as much in class anymore. People I think are using them more on their own laptops. But just be aware that it could get rebooted if you're doing that. But Cat3, Cat4, and Cat5 never will. If you're on a Windows machine, there's a utility that the UW makes available called Secure CRT, which you can get through software.wisc.edu. That's a secure shell client for Windows. There's also I think it's open source version of a secure shell client for Windows called PuTTY. I have a web page there. It's tilde/Windows X Windows that talks about how to install PuTTY and a program called Xming, which is an X server. If you log into one of these, the graphical system that you see on here on Unix and Linux is called X Windows. And it's a client server based thing. So you can actually have an X server running on one machine and have a program that's running on a different machine displaying its output on your server, which is what this is. If you install Xming on Windows or something called Xquartz on a Mac, and of course you can just secure shell right from the terminal window on a Mac, you can remotely log into these machines and run X Windows programs like Genpack or other things and have them display on your computer. And this page explains how to set that up on Windows if you have a Windows machine. And when you first log in, when you first SSH in, from Mac it would be SSH, your username, and then like cat3.aos.wisc.edu. Put a -Y on there if you want to forward the X Windows traffic through the secure shell connection to your computer, to your X server. And then you'll be in your home directory when you first start, which is the same as the terminal here. When you're done, you can type logout or exit, or sometimes Control-T will log you out or close the window. If you're on the machines in here, it's best to go up under the system and choose logout, your username, so that it logs you out. If you stay logged in, it'll go to sleep or it'll go to like a screensaver after a while. But if you're logged in and you walk away, somebody else could get on and delete your files or do malicious things. It's generally a good idea to log out before you leave. So, any questions about that so far? Okay. Usually I set people up with a default password in here. well, to change your password, the command is PASSWD, or we start with the abbreviations, right? Just kind of a whole word. If you type the PASSWD command, it will ask for your current password. Type that in. It won't show the characters or anything. It'll just be blank. And then it'll ask for your new password, and then it'll ask for the new one again to make sure that you typed it correctly. And assuming that it's successful, then you'd use the new password to log in going forward. If you forget what your password is, like you work here for the spring semester, and then you go home for the summer, and you come back in the fall, and you're like, oh, I don't remember my password. Come and see me, because I can't tell you what it is, but I can change it for you. I can get on as the administrative user, and you can type it in. So that's the command to change your password. A couple of commands. If you're logged in and you type ID, it will tell you what user you're logged in as, which is useful for people like me, because sometimes I'll switch to different users to try to figure out why they're having problems or whatever, and I'll use that command to figure out who I'm logged in as. There's a groups command that will tell you what groups you are a member of. Usually you are a member of a group, which is usually users, or in this case it's a group that's the fall of whatever semester you first got in accounting here. But you can be a member of other groups too. For example, on our Jupyter Hub server, I have a group for the people that are allowed to use the Jupyter Hub, and your username has to be in that group, or it won't let you get some weird error. There's a special user on all Unix systems called root, which is the super user. It's the administrative user. They can do anything. They can look at any files. They can delete any files. So it's like having admin access on Windows or Mac, basically. Okay, so that's how you log in and log out. I'm going to talk a little bit about the file system on Unix, because it can be confusing and a lot of people are mystified, and once you sort of figure it out, a lot of what we do makes a little more sense. It's not quite as confusing. So on Unix, basically everything is a file. Your files are a file, your directories are a file, the disks are a file, the monitor is a file, everything is a file. There are ordinary files, which are what you're used to working with, right? Text files or music files or videos or images or whatever. There are directories, or what you might call folders. That is a file that holds other folders or files in it. You can use those to sort of keep things organized. So like in here, I'll give people only one account for the whole time that they're here, and you can make directories in your account for each class that you're in, for example, or different projects that you're working on, to try to keep things organized. Or you can be like me and just have everything in your main directory, and you've got like 30,000 files out there. There are special files which are used to represent physical things like printers, disks, mice, parts of the computer itself that they use. And then there are these things called pipes, which is a temporary file. One of the cool things about Unix and Linux is you can use the output from one command as the input to another command. So a lot of Unix commands do like one small thing, and they do it really well, but just one little small thing. But if you take a bunch of those things and kind of link them all together, you can do some pretty complicated stuff by using the output from one command as input to another command, which could be the input to another command. And pipes are the things that are used to hold that output as it goes from one to the other. Every directory on the Unix file system, including your home directory or any other directories that you make, before you do anything and put any files in or directories in it, is going to have two special directories already in it. One of them is called .. It's just two periods. And that is a special directory that refers to the parent directory, which is the one above wherever you are in the file system right now. And I'll explain a little bit more about how the file system is laid out, and that might make a little bit more sense. So the .. directory is always one directory above where you're at, and then the .. directory is a special directory that refers to this directory, like whatever directory you're in right now, the .. directory is this directory. Every directory is always going to have those two things in it, even before you put anything else in there. And I'll explain why you might use those in a little bit. The Unix file system is organized as a hierarchy or a tree of directories, starting with the root directory, which is referred to with the leading // So the slash is sort of like the Windows My Computer, or on a Mac, kind of like the Finder, where you go in there and everything else is underneath that. The root directory is the very beginning, and everything else is underneath that, or like in a tree, the root would be like the trunk, and then there's branches and leaves and stuff like that. So it kind of looks like this. This is one that I put together. There's the root file system, and underneath that, there's maybe a /bin, maybe there's a home, maybe there's /home class false 06 poker. That's my home directory on our systems. There might be a dev directory where all those weird special files, like having to do with disks and mice and stuff, live. There might be a /etc directory, which is where a lot of the administrative stuff is. Lists of users, lists of permissions, configuration files for different services that are running on the computer. Usually there will be a home directory on a Linux system, and that's usually where the user directories live underneath /home. There might be a lib, I'll talk some more about these in a second, but that's sort of how it's laid out. Here's another more complicated one that I found. I think that's kind of cool. These are a lot of directories that are on most Unix systems. I'm not going to go through all of them, it just sort of gives you an idea what it looks like. So when you first log in, it drops you in what's called your home directory, right? You own your home directory and everything underneath it. Everybody who has an account on the system will have their own home directory, and they will own the stuff in there. And there are ways of allowing or restricting permissions for other people to access that if you want them to or don't want them to, and I'll talk about that in a little bit. So in this classroom, I usually put them under /home1, /class, and then fall of whatever semester I happen to set up your account. And then you just use that through the whole time that you're working here. If you run open terminal, it either starts in your home directory, or like I said, if you right click in the background and do open terminal from there, it'll start in the desktop directory in your home directory. I usually try not to do that because it's just confusing. But you can, if you do it that way, you can always change back into your home directory. If you open it and it's in the desktop directory, you can just say cd ... right, that directory up above, and it'll put you back up in the home directory. So you're not like trapped there. There's this concept of your current working directory. In other words, what directory are you in right now? Anything that you do and you don't specify a path, like if you're saving a file or editing a file or whatever, if you don't specify a path where that's supposed to be, it will be in the directory that you're in right now. And you can find out what directory you're in by using the pwd command. That pwd, which stands for print working directory, it will print out what directory. And so if you're in our in here and you're in your home directory, it's going to be either /home /class /follow something /your username, or it might have a /tornado in front of that because tornado is the server that they all live on. They're actually connected under /tornado, but then I've got links so you can just say /home1 and they goes to the same place. I talk about links a little bit later too. So it starts in your home directory. PWD will tell you what directory you're in, and then I want to talk a little bit about absolute versus relative path names. So an absolute path name to a file or a directory in Linux is the full list of directories all the way out, starting with that leading slash. So like from my home directory, if I've got a directory in there called dir1 and a file in that dir1 called file1, the absolute path that points to that starts with the leading slash /home1 /class /follow6 /poker /dir1 /file1. That is an absolute path name because it starts with that leading slash. A relative path name is relative to wherever I am right now. So if I first log in and I'm in my home directory, right, my current working directory is home1 class follow6 poker, right? That's my home directory. That's where I'm at right now. I can refer to that same file when I'm there as just dir1 /file1 without the leading slash. If I put a slash in front of it, it won't find it because it's looking all the way up. You know, it would assume that it starts over here and it doesn't. Does that make sense? That can be confusing for people when they try to figure out where things, they'll save a file somewhere and then they don't remember where it is or how to find it. Okay, let's pretend now I was in my home directory and I changed into the dir1 directory from that previous example. So I'm changing into this directory with the cd command. CD means change directory. So now when I'm in there, there's a bunch of different ways that I can refer to that same file. I can still refer to it with that absolute path name because that hasn't changed, right? Even though I've changed into directory 1, I can still talk about that file with the full path name all the way to it with the leading slash. But now I can refer to it also as just file 1 because my current working directory is now directory 1, dir1. So I don't need to put the dir1 in front of it. I can also refer to it using that special folder two dots, which means the directory above me. If I say /dir1/file1, that means go up a directory, now I'm in my home directory /dir1/file1. Or I can refer to it with a dot in front of it, which the dot means this directory /file1. All of those things, if I've changed into dir1, all of these things refer to that same file. Does that make sense? And then, I mean, you might, a lot of times where I'll use this is if I'm in a directory and I want to refer to something that's in another, you know, if I want to refer to something that's in dir2 in my home directory, I could just, instead of having to CD up and CD down and all this stuff, you can just say /dir2/file2 or whatever, without having to change out of that directory. Okay. Common system directories, we talked about the root directory, that's like the very beginning of everything. Everything else is underneath that. /bin, and it's usually referred to as like slash or slash, root or slash, I call it slash. So the bin directory /bin is a place where there are sort of common programs, programs that are typically used by users, you know, regular users. There might be a /boot directory, which has like startup files that are used when the computer boots up. Sorry, the dev directory has a lot of those special files, references to hardware, disks, and monitor and mice and stuff like that. Etc. has a lot of administrative or configuration files and programs, like the list of users, list of what groups you're in, printers that are set up on the computer, configuration settings for servers and things like that. Let's see, in RD with some home directories, that's where user home directories live. We talked about that a little already. There might be, this may have some information about how to boot up. /lib usually has shared libraries that are sort of common code that's used by a lot of different programs, not necessarily by you, the user, but when you run a program, you might access stuff in there. Or if you're programming, you might access stuff in there and having to write your own code to do that stuff. Lost and found is if the files, if you have like a power outage or there's some other issues with the file system, it will try to save data as much as it can and will put those things in this lost and found directory. If there's a corruption of the file system and you run a file system check, anything that's like weird about it, it'll put it in there so you can go back and maybe get things back if you get lucky, I guess. We just had an issue with that. We had a power outage here on Friday, and one of our users, he was getting IOS, so I went and ran a file system check on his file system, and there were like 4,200 things that somehow got corrupted or partially lost, and they're all been lost and found with the numbers for file names. So he's going to have to go through and like look at the contents and see if is this an NCF file, is this a code that I had, or he thinks a lot of it is like backups and things that he has elsewhere, so I think it's okay, but that's where that stuff ends up. There might be a miscellaneous directory for miscellaneous things. There's usually a /mnt folder or directory that is where if you're mounting a file system, a lot of times it gets connected in there. If you're attaching a file system to the computer, a lot of times that's where it goes. I think on Macs that typically is /volume or volumes, like with a capital V. Like if you plug in a USB drive or whatever, it'll show up in there. /net, I don't use that, but sometimes it's used if you're using a remote network mounted file system. A lot of times, third-party software will go in a directory called /opt. Usually, most of the operating system stuff goes in the normal places like bin and lib and stuff, but if you install other packages from other vendors or other people after the fact, Sometimes they'll put in the /opt directory. A couple of things that I know that go in there, there's some RAID controller management software that I use that ends up in there, and the Intel Fortran compiler, or C compiler, if you install that, it usually ends up in there also. A lot of times there's a proc file system, which is, it has to do with information about individual programs that are running and their resources live in there. There's usually a /root directory, which is different than like the /root, like the beginning of the file system. There's a /root folder, which is the home directory for the administrative user root. Remember I talked about a little bit ago, there was this user called root who was the super user. Their home directory is in /root, usually. Usually there's a /tmp, which is a temporary area where if a program is doing something and it just needs some temporary space to hold something and then it goes away when you're done running the program, it'll usually put it in there. /user, that's sort of a catch-all. There'll be a lot of things underneath it, so there'll be like a /user /bin, user /lib, /user /local. And as best as I can tell, the directories that don't have a user in them, like /bin, /lib, those are usually things that you would need access to if you were doing a repair on the machine. If it wasn't completely coming on, you didn't have access to everything. Tools that you need, like in a really low level of the operating system, live in those like /bin, /lib. Other programs that normal users use, like the list command or the copy command, things like that, usually live under /user, /bin, /user, /lib, stuff like that. So that's kind of more stuff that like normal users would use as opposed to just the administrative users. Usually there's a /var. That's sort of another temporary type file. Operating system updates, when they get downloaded, they usually end up in there. Mail, if you're using any sort of mail stuff, that usually ends up going in there. Temporary files for printing, if you send a file to the printer, it usually gets stuck in there until the printer is done with it and then it goes away. Those kind of things. There's usually a user include, /user/include folder, which has C and other programming language include files, which is sort of like common code that definitions of things and stuff like that. So for example, on here, /home/AOS would be the home directory for the AOS user. We talked about this already. That's what my home directory looks like. Your home directory looks similar to that, except it probably has like fall 21 or 22 or 23, depending on when I set your account up in here. Or if I haven't, do you have an account here? Not yet. Okay, so if and when I do set up an account for you, if you take a class that's using these computers, you'll end up in fall 23 or fall 24 or whatever it happens to be. User local, that's usually stuff. So when you install the operating system, there's a bunch of stuff that gets installed, and all of that stuff usually gets in either /bin or /userbin or userlib, stuff like that. There's a whole lot of software out there that you can add later on that's not actually part of the operating system, but it runs, like downloading a program for Windows or Mac or whatever. Usually that stuff ends up in user local. And the reason is why I would put it there is if you had a machine crash, you can back up the stuff in user local, because if you had to reinstall from the source, all of the stuff in /bin and /user, that stuff you just reinstall from the operating system distribution, USB or whatever. But the stuff under user local is stuff you added later that doesn't come with the operating system itself. So usually I'll back up stuff in user local, so I've got a copy of it if I have a crash. But I won't bother backing up, other than configuration files, I won't bother backing up stuff in user or in /bin or userbin, because it's going to get reinstalled if I have to reinstall it anyways. And then under user local, there will be like user local bin, which is the binary files, the program files. User local lib, which is like shared library files for a bunch of stuff. User local include would have like include files, stuff like that. Does that sort of make sense? Any questions at all? Okay. So We talked about Unix is case sensitive. Most stuff is lowercase, so ls lowercase is not the same as capital. Usually, in almost all cases, case matters in file names, in program names, everything. The prompt is where you enter your commands in the shell, and if you're running a C shell or TCSH, it'll be like a percent and a number sign, and then it'll get incremented with every command that you run. Usually, if you're running the Bourne shell or KSH or bash, it will have a $sign as a prompt or a number sign as a prompt. Similarly, if you're in a root shell, a lot of times that will change somehow to indicate that you're logged in as root rather than as a normal user. And you can change that. You can, in your startup files, you can modify how that prompt looks. Some people will want to have the machine name on there. Some people will want to have it so it updates what directory you're in as part of that prompt. This one has my username on there, and then what command number and the list of the history that I'm currently typing. We'll talk about the history in a little bit. For commands in Unix, typically it's the command name, which is usually an abbreviation. Then a series of flags with a hyphen in front of them, and then a bunch of arguments like what is this command going to operate on? What am I going to do? This command is going to do something. The flags are going to maybe modify how it does that something, and then what it's going to do that something on is the arguments afterwards. As you're typing a command, you usually use the backspace key to erase characters, but sometimes when you do that, there's two different backspace keys, and Windows and Mac and Linux all use different variants of it. There's a backspace and there's a delete. And if you're on a machine, if you're remote logged into a machine that uses one, but the computer you're on uses a different one, you'll get weird characters like caret, question mark, greater than sign, or something weird like that. If that happens, here's a little trick. You can type STTY space erase space and then hit your backspace key and then enter. And it will change what the delete key is supposed to be to whatever yours is sending. So from then on, in that terminal window, before you close it, your backspace key will work correctly, or should work correctly. And if it's a common thing, you can put that in your startup file so that every time you log in, it does that. So Unix and Linux operating systems have online manual pages for almost all of their commands. The command to look at the manual pages is man. So if you type man space ls for the list command, it will give you a manual page about how to use it. Because the list command has about 24 options to it. I go over like 3 of them maybe in this talk. But you can go and see what they all are, and it will change how the list command works. If you want to figure out how to use the man command, you can type man space man, and it'll show you the manual page for the man command. If you want to learn about the password program, you can type man space password, and it'll tell you all about how to use the password program. If you know sort of the idea or the concept of the program that you want to look at, but you don't know the name of the program, you can do a man-k, which searches based on the description rather than the command name itself. So if you did man-k space compiler, it's going to show you a list of all of the different compilers that it found, and then you can do a man on any one of them to find the man page on that. The thing about man pages is they're written by computer geeks, so they can be sometimes hard to interpret, and they're kind of geeky. So if you are reading a man page and you want to translate it into like normal human English, I'm happy to try to do that for you, because I speak geek too. Okay, every Unix command that you run is going to have the process ID. Excuse me. That is what the kernel of the operating system uses to keep track of them. There is a command called PS, which you can use to look at and manipulate the command process IDs. So if you just type PS, it'll show you all of some information about all of the processes that are running in the shell that you're in. You can type PS minus FLU and then your username, and it will show all of the commands on the operating system that are running right now that are owned by you, or me in this case. If you do a PS minus EFL, it will show you all of the commands that are currently running on the operating system, including operating system processes, so you get like 100 of them maybe. Sometimes if you're on a BSD, this is, remember I said there was like AT&T Unix and BSD Unix, and there were some differences. This is one of those. If you want to get the same kind of output on a BSD type system, you type PS minus AUX. It's different ways of getting the same sort of output. And that's one way of sort of figuring out, am I on a BSD or an AT&T type system? Because one or the other of those will most likely work. So if I do that, if I run PS minus FLU and my username, you're going to get some output that looks like this. It's actually usually on one long line, but it didn't fit on the screen, so it's split over two. I'm currently on this operating system running 3 processes, and it looks like I'm actually running a MATLAB license manager there. But the columns on here that are interesting, this tells you who's running it, that's the username of who it is. That's the process ID that the Unix is using. If you wanted to kill it, you can use that number. The parent process ID, so in this case, I ran this command and its parent process is like the operating system, like it's the first process. It ran this one and then this one ran that one. So you can kind of work your way down the process list that way. The C tells you how much CPU it's using. That'll be a number from 0 to 100, or it might be higher if it's multi-threaded and using more than one core of a CPU. The priority and the nice have to do with the priority in terms of the scheduler, how much CPU it's being allocated out of all of the CPU stuff. This address thing has to do with like where in the memory it's actually located. That doesn't really matter. Same with this WChan thing. I'm not even sure what that is. The size tells you how big it is. So if you're running a job or running a program, that'll tell you how much memory it's occupying. And then there'll be a date and a time of when it started and a time of how long it's been running. These apparently I just started or they're not using a lot of time. And then this is the actual command you can run. So if you're running programs, where this comes in handy is if a program gets hung or consumes a lot of resources and also you can't do anything on the computer. If you can figure out the process ID of that command, you can kill it and get the computer back without having to do it. In a particular shell, there's a shortcut. They have like these job numbers, which are not the same as these process IDs, which are across the whole operating system. In a particular shell, whatever commands that you run in the foreground or in the background are going to show up as individual jobs starting with 1. And by foreground or background, what I mean is, like Firefox is a program that opens its own window and do stuff in there. You can start Firefox from the command line on Unix. You just type Firefox. But if you do that, then the terminal window that you started it from, it just sits there. And you can't do anything else in it because it's running Firefox, which is this own window that you're doing. And you really don't need to waste a whole terminal just sitting there running Firefox. So if you put it in the background, it'll run Firefox and continue running, but will return control to the command line. In other words, you'll get another prompt and you can do other things in that same window, even while Firefox is still running and attached to that window. And you can type jobs and it will show you that. So for example, here, if I wanted to kill a program, if I can get that PID, which is this number here, from the PS command. If I want to kill a process, I can type kill and then that number and it should kill it. It should stop it. If you want to pause it so it's not using any CPU but it's still in memory and you want to restart it later on, pick up where it runs off, or where it left off, you can send a stop signal. So if you type kill space minus all caps stop, and then that process ID, it basically leaves it in memory but stops using any CPU on it until you want to send a continue command. I used to use that when I worked with Greg Tripoli. We did research model runs, but we also ran an operational run a couple times a day. And we wanted to be able to have the research runs going when the operational run wasn't. But we wanted to pause the research runs while the operational run was going so it would get done as quick as it could. So when it was time to start the operational run, we would send a stop signal to the research run, it would just pause. and then the operational run would go, and as soon as the operational run was done, you would send a kill minus CONT for continue, and then the other job would just start right up where it left off, and we just continue on from where it was. So like just pauses it, I guess. There's a number of different signals, they're called, that you can send to processes, and sometimes they'll like force it to reload a configuration file. Sometimes they'll do other things. The -9 signal is sometimes if you kill a job, if there's something weird going on, sometimes it won't actually die. It sounds morbid, but when you send a -9 signal, it's like, look, man, I'm serious. I want you to die, right? And usually, if you kill a process and it doesn't die, and you send a kill -9, usually it will die. If it doesn't, then you probably usually have to reboot.
Is it like a force quit on a Mac?
Yes, very much like a force quit. That's probably what a Mac is doing when you do that. But I don't know. Yes, very much like that. Good analogy. Okay, and these jobs things that I was talking about before, this sort of thing, protect jobs. If you're in a terminal, you run Firefox, and you don't put it in the background, you can pause it, or effectively send it a stop signal by typing Control-Z. That will send it a stop signal, and you'll get your prompt back when you do that. But if you do that, if it's stopped, and you go to try to do anything in it, you can't type in it, you can't refresh or do anything because it's not running it, it's just paused. You can put it back in the foreground with the FG command, foreground it. So if you type jobs, you'll get a number, like job number 1, job number 2, whatever job that is. You can type foreground or BG to put it in the background, %1. So if you type Firefox and it's running, and you're like, oh shoot, I want to do something else in this window, you can type Control-Z and then BG space %1. It'll start up Firefox again, but in the background, so it's disconnected from the terminal. You'll have your prompt back, you can do stuff, but Firefox will still be running. And that works with other things too, if you've got a model you're running or something. We talked about this already in terms of where commands live. They're usually in /bin or user bin. Sometimes if you're writing your own code, you might have a bin directory in your home directory just to keep it separate from the operating system stuff. In here, when I compile stuff that I want available on all of these machines, I usually put it under /research/linux_bin. I usually put that path in everybody's path when I set up accounts, and it's automatically mounted on all these machines. So I only have to compile it and build it once, and it's available to everybody. I don't have to compile it and do it on every single machine, which is you would have to do if you were putting it in one of these directories that's local to each machine. That makes sense. Okay, I was talking about your path. Linux doesn't look in every directory on the operating system for programs to run. It only looks in certain directories. And those directories are the ones that are in your path. So when you first log in, you typically have a path that's already set, which usually has /bin/user-bin /user-local-bin, common places where there are programs usually live. But if you start adding other software on, it might have its stuff in different places, and for the operating system to know to look there for programs, you have to add those directories to your path. There's an environment variable called, and we'll talk a little bit more about environment variables in a minute, but there's an environment variable called path, which is what the operating system uses. It looks at all of the directories that are listed in that path for programs when you try to run something. And it looks at them successively. So, excuse me. In this case, it's looking in the grads bin directory, then it's looking in this research Linux bin, which I just said that's where I put stuff in here. Then it's looking in Linux IDV, then it's looking in the Kitus bin directory, then CL bin, user local weather bin, and then user local bin /bin/user bin, a bunch of places, a Genpack directory. So if you type a command without specifying the full path name to it, it's going to look through all of these directories, and whichever one it finds first, that's the command it's going to run. This confuses people a lot of times because, especially with like scripts, if you write a Genpack script and it's in your AOSS 452 directory or whatever, and if you just create it and then you make it executable, which we'll talk about in a minute, and you try to run it, it'll say command not found. And you're like, It's right here. What do you mean? Can't find it. Well, remember that dot directory I talked about earlier? If you put the dot directory in your path, it will look in the current directory, whatever you happen to be in, for programs as well. And it's generally good practice, if you're gonna put the dot directory in your path, it's good to put it at the end of your path. If you put it earlier in your path, somebody could maliciously put like a system program like List or Firefox or whatever in your directory, and then when you run it, it's gonna run that version rather than the operating system one, and they could do something malicious that way. So it's usually a good idea to put that at the very end or close to the end of your path, so that if there's an operating system executable, you'll find that first before anything in your own directory or whatever directory you're currently in. So it'll look through all these directories for programs to run. In the C shell, it keeps a hash table. It goes out and looks for things to run, so it doesn't have to search these every time. Because of that, if you make a change to your path, it won't actually look in the directory that you changed until you refresh that hash table, which is what this rehash command does. So if you're running C shell or TC shell and you make a change to your path variable, you have to type rehash before it's actually in effect, before it actually makes a difference. Another way around that is for the case where you have a program in the directory you're in now and you want to run it. If the dot is not in your path, you can specify / and then that program, and then rather than having to go out and search through the path, you're saying I want to run this one. Run the one in this directory. So that can be handy for Genpact scripts as well. If you want to find out where a program that you're running is, there's a couple of programs you can say where is. So if I type where is pwd, it'll find one in /bin/pwd and in /user/bin/pwd. If you want to find out which one it's actually going to run, it'll search through your path and return which one it's going to run. So if I type which pwd, in this case it says /user/pwd. So if I type pwd, that's the one that's going to run. Okay, one thing that's interesting about Unix is you can link commands together in different ways. Remember I was saying earlier, a lot of commands are really good at doing one thing and they do it really well, but it's pretty limited, but you can string them together and make really complex commands. You can do several commands, one after the other, separated by a semicolon. So if I ran the listing command, that would show me a list of all the files and directories in my directory, and then the date command tells me like what date and time it is, one after the other. Those pipes I was talking about earlier, in this case, I've got like 30,000 files in my home directory because I never use subdirectories. So if I do a long listing, I'm going to get this huge list of files, and it's just going to take forever to scroll my screen. If I pipe that output into a program called tail, which we'll talk about that in a little bit, but it by default shows only the last 10 of whatever you ran it on. So this thing, it would show a long listing of all the files in my directory, but only the last 10 of them. And you can organize that alphabetically or numerically or by date when you did a backwards date, so the newest ones are on the bottom and the top. So those are kind of handy. If you want to run a command in the background to start out with, and without having to do that Control-Z background kind of thing I was talking about, you can type the command name and follow with an ampersand, and that automatically puts it in the background. So it will just immediately disconnect. It'll run it, but you get your prompt back and everything, and you can do other things at the same terminal. Okay, I talked about command history. If you type history, it will show you a list of all of the commands, or a certain number of the commands that you've recently typed. They'll have a number in front of them, and you can use that number to access those commands. If you type 2 exclamation points in a row, it will repeat the previous command that you just did, so if you just want to rerun the same thing rather than having to type the whole thing, then just 2 exclamation points, it'll rerun it. If you want to rerun the previous command that started with something, so if I did ls minus L and I want to rerun that, I can just type exclamation L, and it would find the previous command that started with L and run that command. Assuming I didn't have any other commands that started with L since the last time I ran the ls command. you do this history thing, like I said, it has a command number on it. If you want to rerun a specific command by number, like the 23rd command that you happen to have, you could type exclamation in that number. N could be 1 or 50 or 300 or whatever it happens to be, and it'll rerun that command from the history. And in TC shell, there's a way, this is kind of weird, but you can rerun a previous command by replacing a string with something else. So if you type caret and then something that was in the previous command and then caret and what you want to replace it with, it'll rerun the command swapping new for old. If that makes sense. Probably a simpler way to access your command history and how I normally use it is with the arrow keys. So if you start hitting the up arrow, it'll start cycling back, and you'll see on the command line, it'll scroll through all the different commands. When you find the command that you want to run or modify, you can use the left and right arrows to scroll along the command line and change it. So you can backspace out and type in new stuff. If you've done that, you don't actually have to move the cursor all the way to the end of the line to run it. You could be in the middle of the line and just hit enter and it'll just deliver. In the TC shell, if you type Control A, it will automatically move your cursor to the beginning of the line. And if you type Control E, it will automatically move it to the end of the line. So if you want to just quickly move without having to scroll, with the arrow keys, those are some shortcuts. There are some other commands like that that you can use, like move back a word or something like that. I don't talk about all those in here. Any questions on anything so far? So you guys can just keep asking. Okay. When you run a command, there are 3 places that it either looks for input or sends its output by default. Those are called standard input, standard output, and standard error. Standard input is usually the keyword. If you run a program, it's usually going to be looking for input from you typing in the keyboard. Standard output is usually going to scroll up the screen. If you run a command and it enters any output that it has, it's usually going to go scrolling up in the terminal window or if you're logged in remotely, where you type the command, it's just going to go scrolling up the screen. Standard error is also usually the screen. And the difference is standard output is any output that you told the program to write. So if there's a print statement or something, you said print x equals whatever, and it prints x equals 5. Standard error is when something went wrong, like you refer to a variable that doesn't exist and it crashes the program, or you try to divide by 0 and it crashes the program, or something weird like that. Output that you didn't tell the program to create, but it created it because of some error condition. Usually those both go to the screen, but it's possible to have them go to different places. They're 2 separate connections to the program, and it's possible to have them go other places. You can redirect that standard input and standard output to a different place using the greater than and less than and ampersand characters. So let's use the list command as an example. This will show all of the files and directories in the directory that you're in. Normally it just scrolls up the screen. If you do ls greater than and then some file name, it'll send that list output instead into a file, and it will overwrite that file if it exists, if you use just a single greater than sign. So that's handy if you want to capture the output from a file for an assignment and email it to your TA or whatever. You can do that pretty easily. If you use 2 greater than signs in a row, it'll do the same thing, but it will append to the end of an existing file, or it'll create a new file if it doesn't exist, but it won't overwrite the file that's already there. That only puts standard output. If there's any errors, they're still going to go to the screen. So if there's if you're having a problem, you're like, Pete, this program's not working, why is it not working? If you just send the output from the file, but the error is on the screen, that's not going to help you at all. If you do a greater than with an ampersand after, this is all in the TC shell. It's a little bit different in Bash. But in the TC shell, a greater than ampersand will put the output and the error in that same file. So all of the output, standard output and standard error go there. Same thing with redirecting it, but appending it if you use 2 greater thans and an ampersand. It's also possible to redirect the standard input so that the command takes its input from a file or some other place instead of the keyboard. So if you've got a file that has a list of files and directories that you want to list, you could say ls less than file, and it will list taking its input from that file. You can do this a similar thing with this two less than signs in a row. We typically you'll see that when you're doing Genpack scripts, where Genpack, usually you run a program and then you have to set a bunch of variables, and then you run the command, and then you exit and hopefully type GPN at the end of it. If you're doing it in a script, what you'll do is you'll run the Genpack program less than, and some string. I mean, it doesn't have to be Word, it could be EOF1 or hello or goodbye or whatever. I mean, it could be anything. It has to be the first thing on a line and unique, and the only thing on the line, so you don't want anything after it. So in the case of Genpack, I'll show a Genpack script at the end here, how that actually works, but I don't think I show the script. I've got an example you can copy. But you run the Genpack program less than EOF, for example. And then you put a bunch of lines that set all the Genpack variables, and then you run it, and then at the end you type EOF, and that ends the input to the Genpack program. That's usually where I end up running into that sort of thing. But I can imagine there's other cases where that would be handy too. Okay, we talked about the pipe already. Here's an example again where you do a long listing and pipe it in the tail. You can, I talked about earlier a little bit, making aliases. So if you find yourself typing excuse me, if you find yourself changing directory into a really long path all the time, every time you log in, you got to change into this and this and this. You can make an alias, like 2 or 3 characters that run that longer command. So you only have to type the short one. So for example, this version of list is something I like a lot. It does a long listing which tells you information about like permissions and how big the file is and who owns it. It does it in time order and reversed, so that the newest files are at the bottom and the oldest files are at the top. And then the capital F does things like it'll put an asterisk next to a file that's executable. It'll put a slash next to a directory name, stuff like that. It's not actually part of the file name, but it tells you what kind of file it is. So I usually will alias LL to be like a long list command, and it runs this command when I run it. A lot of times I'll make one called LT. A lot of times if I'm doing a long list, I only want to see the most recent files. I don't care about stuff from months ago or years ago. So I'll make an LT command which runs that long listing but pipes it in detail, so it only shows me the last 10 lines of that long listing. Here's an example where I'm changing into this big long directory name, and I can just type arch, and it'll run that command and change me into that other directory. That can be really super handy in terms of not having to type as much and preventing typos and wasting time. Sometimes you'll have commands that are too long for one line, and you can just keep typing. But for readability, sometimes it's nice to just stop and continue your command on the next line. The line continuation character is a backslash, so it's like this one, not this one. Technically, what that character does is it removes any special meaning of the next character. So we'll talk a little bit later about special characters, like an asterisk means anything. Like if you want to do ls, L star, it'll show you any files that start with an L and anything after them. If you want to actually use a star in a file name, which I don't recommend, but if you did, you could put a backslash in front of the star, and it gets rid of the star means everything, anything, and it actually means just a star. In this case, if you type a line continuation or the slash and then enter, it gets rid of the special meaning of enter, and it just moves you to the next line. That's technically how it works.
Question about
Yeah.
alias, just
Yeah.
for clarification.
Yep.
So once you type like alias, that first line, alias LL, and then your string or whatever, do you have to type alias again when you want to do that, or is it now just LL?
So this is just defining.
Okay, yeah, that's what
This
what I
won't
thought.
actually run it.
Yeah.
When you run this command, you'll
That's
just get prompt type.
defining it, and then from
It's
there on, it's defined, so you
Just
don't have
type
to
LL. Now, if you do that in a terminal window, it's only going to be active for that terminal session, and you log in next time, it'll be gone.
Okay.
But you can put these in your startup files, which I'll talk again about in a little bit. Then every time you log in, they'll automatically be there. Yep. Good question. Okay, so the line continuation character is a backslash. You might want to do something, and this is where I have to talk about Michael Morgan. He's a professor here on leave. He's actually working in NOAA right now as like the head of half of NOAA. But when he was a professor here, he wanted to do something, he wanted to do some cleanup, and so he wrote this script. And he did /bin/remove, which means delete, -r is recursive, and I think he had an F next to it, which means force, which means don't ask me any questions, and a backslash, and then a whole bunch of things that he wanted to delete. Except he used a /. Remember what the / is? So he did remove recursively, don't ask me any questions, root, and a bunch of stuff after it. He ran the command. About 10 minutes later, he's like, this is taking a really long time. I wonder what's going on. So he Control-C to stop it, and which killed it. And then he did ls, and it said command not found. df command. He's running all these Linux commands. Basically deleted like half of his operating system because he ran it as root, and he deleted everything. We had to reinstall his whole operating system because he accidentally deleted it. So be very careful when you're using the line continuation character. Make sure you use the backslash and not / because you can cause a lot of. If you do it as your own user, you might delete all your stuff and not the operating system. But still, that's pretty catastrophic. You know, day before a final or something, you delete all your stuff. Anyways, if you see him, ask him about that. Say, deleted your operating system.
How about that /?
Yeah, right. That was pretty fun. Anyways, okay, so shell scripts are kind of like extended aliases almost. They're like batch files. We'll typically use them for Genpack programs because Genpack, you have to go through and set things, and once you get something sort of the way you like it, if you have it written as a script, it's really easy to just like modify one thing and all the rest of the stuff is already set up for you. You can just make a copy of it, change the variable to plot everything the same with just a different variable, that kind of stuff. Basically, a shell script, you just put a bunch of commands in a text file as if you had typed them at the prompt, and then make that program executable, which I'll tell you about in a minute. Here's an example of what it might look like. This first line is going to start with a number sign, exclamation point, and then what you want it to run under by default. In this case, it's going to run with C shell, but that could be Bash or it could be Python or something else like that. Then I'm going to just say good morning, today is whatever today's day is, and then remember everything you need to do. Like just some stupid little script. But it's going to run all of those commands with me just typing this one thing, one file. And we use that a lot for Genpack plots, which we'll run into in our 452 and 453 classes. Okay, having done all that, this is just a bunch of ways. I'm talking about ways of creating files now. There's a command called cat, which typically concatenates files, or if you just cat some file, it's going to scroll it up the screen. It's going to send its output to standard output. In this case, I'm going to redirect into the standard output into a file. So if I say cat > file1, type in some text, and then press Control-E, it's going to put that. It's going to create a file called file1 or overwrite the file if it already existed, and this text will be put into it. If you have a bunch of files and you want to concatenate them all together, you could do it cat file1, file2, file3 into file4, and after that command, file4 will exist and it'll have the contents in order of file1, then file2, then file3, all in that file. Be careful because it actually creates the new file before it reads the old one. So if you did something like this, cat file1 and file2 into file1, you're going to end up with just the contents of file 2 because file 1 gets nuked before it has a chance to read it. In this, the echo command echoes output to the screen. I usually use that if I'm running like a big batch file to say, okay, you're here, and you ran this command, you did this, whatever. Just sort of commentary. But if you echo some string and put it into a file, that'd be another way of creating a file 1 with this text in it. You can append text to that file with the 2 greater than signs that we talked about earlier. If you want to create a file or update the modification time of an existing file, you can use the command touch, which will just create an empty file, in this case named file. A lot of times I'll use that if I've got multiple things that are running and I want them to sort of communicate with each other. Like, I don't want this second program to run until the first one's done. So the first one I'll run, and when it finishes, I'll say touch, program 1 is done. And the second program will be running and looking to see, does that file exist? No, wait, no, oh, there it is, now I can run. That's usually why I use it. Or, like I said, if you want to update the modification time, usually if you create or edit or do anything to a file, that's the file that will show up on a listing. If you want to update that to be now, you can just touch it, and it doesn't change the file, it just changes the update time of it in the file system. Usually you're not going to do that though. If you're going to create a file, usually you're going to use a text editor. And a text editor, as compared to like a word processor, like Microsoft Word or whatever, you can do things like bold or formatting of files or headings and stuff like that. A text editor is just text. It doesn't matter what, it's just letters and numbers and spaces and symbols, which usually is what you want for like programming and stuff. You don't care about bold or other stuff like that. There's a number of different text editors that are out there. VI is one of them, and I've got a little bit about that at the end of this talk. There's one you might run into called Nedit or gedit, which are sort of like Notepad or the text editor on a Mac. They're just straightforward. You use a mouse, you need graphics to use them. Nano and Pico are text editors that don't require graphical output. So if you're logged in remotely and you're just in a terminal window, you can use those in the terminal window. Same with VI. Emacs is a fairly powerful editor as well. It works either in a terminal window like these guys do, or if you're on a graphical system, it has a graphical mode also, so it kind of does both. Within Unix, there's kind of a religious thing between VI or Emacs. Some people prefer VI, some people prefer Emacs. Professor Morgan only likes programs that get installed with the operating system, except for Emacs. Emacs is his like one exception. Like, he doesn't like VI, he prefers Emacs, even though it doesn't typically come with the operating system. You have to add it on later. So to create a file with VI, you would just say VI and then the file name. If you're using a graphical editor like Edit or gedit, you would typically edit that file name and then an ampersand to put in the background, because it's going to open a window and you don't need it tied to the terminal. I guess I said this already in terms of different editors that are out there. The reason it's nice to know VI is that every Unix or Linux system is going to have it on there always. When you install it, it's there. These other editors are available and you can install them after the fact, but you know VI is going to be there always. Okay, some more displaying files or working with files. If you cat a file, it's going to just scroll the contents of that file up the screen. There are pagers. One of them is called more, one of them is called less. They will scroll up the screen with a pause at each screenful, and usually hit the space bar to get to the next screen. So rather than having the whole thing go scrolling up the screen, you can kind of parse through it. Less is kind of nice because if you know how to use VI, the same commands for moving around a file in VI work in less. So like Control B to go back a page, Control F to go forward a page. You can move through the file using VI type commands with the less pager. We talked about text editors. Head and tail are a couple of commands that will show either the beginning or the end of a file. So by default, it's 10 lines. If you give it a number, so like head minus 20 of some file, it'll show you the first 20 lines of that file. Tail minus 10 or minus 20 will show you the last 20 lines or however many lines you tell it to. That's 10 by default. The minus F option stands for first in, first out. So where I use that is if I run a program and I redirect the output to a file, and that file keeps growing as the output happens, I can follow the output as it's added to the file with a minus F command. So if you do a tail minus F20, for example, it shows you the last 20 lines of the file, but then as that file gets added to it, it keeps scrolling down as it's going on, as it gets added to it. The list command that we were talking about earlier, again, these are all abbreviations. If you type just ls, it's going to show the list of files and directories in the directory that you're in alphabetical order, on kind of a gridded sort of looking view. By default, it doesn't show any hidden files. Any files that start with a period are by default hidden or like excluded from the normal list, including that dot and dot dot file we talked about earlier. If you want to see the hidden files, you can do a -a, which means all, list all the files. So that will, ls-a shows the dot and the dot dot and any other. A lot of times, like the startup files will have start with a dot, or configuration files for other programs will start with a dot. ls-l will give you a long version of a listing and usually one file per line. On this long listing, the stuff over on the left has to do with permissions, and the first character will tell you things like if it's a directory, or if it's a pipe, or some other kind of special file. If it's a dash, it just means it's a normal file. And then there's three groups of permission information, RWX, 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 which have to do with permissions for you, the user, or your group, or everybody else. And I'll talk about that in just a second. This has to do with how many links to the file there are. I'm not going to worry about that right now. The username, that's me, I own it. The group ownership of the file, so that file is owned by the group user, so anybody who's a member of the group user would be able to read it. The size of the file, which is 203 bytes in this case, it could be kilobytes or gigabytes or whatever. The date and time that it was last modified, and then the name itself. So that's what that stuff is in the long listing. Copying files, if you want to make a copy of a file to something else, the command is cp. If you cp file 1 to file 2, it makes a copy of file 1 named file 2. If you copy a file to a directory, it will make a copy of that file in the directory named file 1. If you copy multiple, you can copy multiple files at a time into a directory. So if you copy file 1, file 2, file 3 to directory 1, it will make all three of those copies of all three of those files in the directory dir1. That last, in this case, that has to be a directory, and if it's not, it'll complain and say, sorry, that's not a directory, you can't do that. You can't copy a bunch of files to another file.
And copying, so for that second bullet point,
Yep.
copying file 1 to directory 1, in directory 1 then there'll also be
Correct.
file 1.
Yep, the original
Same
one will
name.
still be there, and there'll be a file in directory 1 with the same name. Yep. Moving or renaming files is the mv command. So if you move file 1 to file 2, it'll just rename file 1 to file 2. If you move file 1 to a directory, it will move it from this directory into directory 1, and it will no longer be in the current directory. You can move a bunch of files into directory 1. So if you want to take a bunch of files and put them in a directory, that would accomplish that. Removing files or deleting files is the remove command, rm. So if you remove file 1, it'll delete it. Generally, there is not a recycle bin or a trash can in Unix, so if you remove a file, unless you've got a backup of it, it's gone, so be careful. If you're new to Linux or Unix and you want to have a layer of protection so that doesn't accidentally happen, you can use the -i option, which means interactive. So if I remove -i some files, it's going to ask me for each file, you sure you want to delete this file? You sure you want to delete this file? You can type yes or no. It's just a little bit of safety that you don't accidentally delete something and wish you hadn't. The -i for interactive also works with copy and move to prevent you from accidentally overwriting a file as well. So if you move a file to a to another file name and that other file name already exists, it'll say something like, are you sure you want to overwrite the file with the one you're moving to it? So that can be handy. And you can alias the remove command, remove -i if you're worried about that. If you want to compare two files, there's a program called diff. The output from the diff command is a little bit cryptic because it's actually was written to be able to work along with a program called patch. So if you have a set of code and you make some changes to it, and you want to be able to send those changes to somebody else, you could get the differences between the code that you had and the code that you now have in this format, and then they could take that output, apply it to the original code, and end up with what you changed it to with the patch command. That's what this whole thing means. Basically, if I've got two files, and in those files, line 1 is the same, but in this one, line 2 is not the same, and this one, line 2 is different, what this is going to output is those two lines, and in the first one, that line is not the same, and that line is different. And this little gibberish here means to make file 2 look like file 1, you have to change line 2 from this to that. I guess to change file 1 to file 2, you've got to change line 1 from that to this, to change 2. That's what that means. You can ignore it. Basically, if you're just looking at what's different, sometimes you've got a Genpack script and one is working, and you copy it, and you change some things, and now it's not working. You can do a diff on them and figure out what's different. One of these things is causing it to not be working for some reason. Okay, there's a program called grep, which will search the contents of a file if you want to search for something in a bunch of files. So for example, here's sort of the general syntax. You can grep whatever it is you're looking for, and then a list of files that you want to look for that in. By default, it is case sensitive, so in this case it would only look for capital expression. The -I option to grep makes it case insensitive, so look for capital or lowercase or any combination thereof. So like if you knew that you had somebody's name in some file in your directory, you can't remember what file it's in, you could grep that person's name star, and it would look at all the files in your directory and return some information about what files had that name in it, and you can find it that way. There's a sort command which will sort files either alphabetically, sort -n will sort them numerically, sort -r will do it reverse alphabetically, and sort -nr will sort in reverse numerical order. That can be handy if you want to sort a file alphabetically, and you can tell it which column to sort it by and things like that. Where I usually use that is there's a command called du, which shows you the disk usage for every file and directory. If somebody fills up a file system, I'm like, right, who's using all the space? I can say du -sk star, which will give me a list of how much space is being taken up by all of everybody's home directories, and I can pipe it into sort -nr so that the biggest one shows up at the top, the smallest at the bottom, or the other way around. And that way I can easily find out where all the space is being used up. That's how I typically use sort. Okay, when I talked about the listing command, I talked about file permissions. In Unix, there are 3 people. There's you, there's your group, and there's everybody else. Okay, you, the user, G, the group, and O for others. There's a command called chmod, which means change the mode or change the permissions of this file or files. There's 2 different ways to use it. You can use it in an alphabetic way, or there's a numeric way, which I'll talk about on the next slide. It would be chmod space, then U for user, G for group, O for other, or A for all of those. And you can use any combination, so you could type UG if you wanted to do user and group, but not others. And a plus or minus, and there's spaces in between each of these chunks. Plus or minus if you want to add or remove this specific permission. And then RWX for read, write, or execute permission. Read means the ability to read a file. Write means the ability to change or delete it, a file, or create it. And X means the ability to execute it as a program. And then a list of files. So you could chmod U plus X file. And that would add execute permission for you, the user, on whatever file you just changed. There's another way of doing it numerically, which you may have run into in 452, where it would be a 3-digit number. This is starting that. It's the sum of 4 for read, 2 for write, and 1 for execute. So if I did chmod 761, this first digit is the permissions for the user, the second digit is for group, the third digit is for everybody else. 7 is the sum of 4 plus 2 plus 1, so I would end up with read, write, execute permission for the user. 6 6 is 4 plus 2, so you get read and write permission for the group. And 1 is just execute, so you have execute permission, but not read or write permission for everybody else. I don't know why you'd ever make a file with that permissions, but it's just an example. So a lot of times you create a Genpack script, and usually when you create a file, the default is read and write permission for you and read permission for everybody else, no execute permission. So if you make a Genpack script and then try to run it, it's going to give you permission denied because you don't have execute permission on it. And the solution to that is usually they'll do chmod 777, which means read, write, execute for everybody. I mean, it's kind of a nuclear option or whatever. Really, you only need to do chmod u plus x is what I usually do, which gives you, the user, execute permission, and then when you try to run it, it'll run this program. Okay, I said that the default usually is read, write permission for you and read permission for everybody else. There's this thing called a UMask, which is a default permission mask, which it gets set when you first log in, but you can change that if you want your default permissions on your files and directories to be different. It's a 3-digit number that gets subtracted from 666 for files and 777 for directories to get what the default permission is before you make any changes to it. The usual default is 022, which ends up with default permissions of, is that right? That sounds like for a directory. Because usually for files, you end up with 644, so there's read and write for you and read for everybody else. You can, in your startup files, type UMask and then a 3-digit number of how you want to set your permissions. You know, something that would be deleted or subtracted from 666 for files and 777 for directories. For directories, this is usually the permission. And execute permission on a directory means the ability to change into it. Like you could list the files of a directory and you could read permission on a directory means the ability to look at what files are in there. Write permission on a directory means the ability to create or modify or delete files in that directory. And execute permission means the ability to CD into it. I think that's what that means. Okay. Wildcard characters, I was talking about this a little before with the backslash. An asterisk will match 0 or any more characters. So if you did ls L star, it's going to show, if there was a file named L, it would show that. If it was L, S, L, O, and L, anything after it, an asterisk would match anything after it. A question mark matches exactly 1 character, so it's kind of like a wildcard, but instead of matching 0 or more characters, it matches only 1 character. So if I did ls L question mark, it would show LA, LB, LC, L1, L5, L question or whatever. But it would not show like Lua, LUA or L, yeah. Three character file name would not, you'd need 2 question marks after it to see those. You can use bracketed ranges or bracketed chunks. So if I did bracket capital J, lowercase j, that will match exactly 1 character if it's a capital or a lowercase j, but nothing else. You can use ranges in there, so bracket 1-5 would match exactly 1 character of any of 1, 2, 3, 4, or 5 in that spot. A tilde is a special character that means it expands to the full path to your home directory. So if you could just say cp space tilde, and it will change directories to your home directory. Actually, you don't have to do that because the default input to the cd command is your home directory. So if you just type cd, enter, it'll go to your home directory. But you can put a name after that. So if you wanted to change to my home directory, you could say cd space tilde poker, and it'll put you in my home directory, if you have permission to go in that directory. And you can use that in the cd command, you can use it in file names. We just ran into that earlier where one of the 452 students was trying to access a Genpack file that was in the TA's directory, and he had to set the GD file equals tilde Patrick slash whatever, and it worked. He went to Patrick's home directory. There's a file command which will tell you what kind of file things are. So if you have a file and you're not sure what type of file it is, A lot of times it'll tell you if it's a PostScript file or a JPEG image or an MP4 file or something. Sometimes with more like AOS specific type stuff like a netCDF file, a lot of times it won't know that it's a netCDF file, it will just come back and say data, that it's some kind of data. There's a find command which you can use with a path to find files. It can be complicated to use. The general syntax is find some path minus name and then whatever file name you're looking for, and then minus print. So that will list out in the path that you specify any files with that file name, and you can use wildcards in there too, so file star or whatever. You can do more than just print though. You can remove files, you could look at the disk space usage of them, things like that. So in this case, I'm looking at my home directory, any files that end in .text, print them out so I can see what all files are there. There's a whole lot of ways that you can use the find command, way more than I can get into. You can do the man page on it if you're interested, or we'll talk about later. There's these things called symbolic links, which are like pointers. So a lot of times, I'll want to have, if there's like a really big file, and everybody needs access to it, but I don't want to copy it into everybody's directories, I can make these symbolic links that point at that file. So it looks like the file's in your directory, but it's actually pointing at a file somewhere else. There's also hard links, which you can do on the same file system, where it would create a new file name that points to the same data on the disk. The difference between a hard link and a symbolic link, or a soft link, if you delete one of the hard links, the soft link or the other hard links still point at the same data on the disk. So until all of those hard links are gone, you can still access that file. With a symbolic link, if you delete the original file, the symbolic link is still pointing to it, but the file that it's pointing to no longer exists and it won't work. It'll just give you an error if you try to access it because it won't be there. I don't know if that really makes a lot of sense, but there's cases where you want to use either one or both of those. Printing files, if you're printing from the command line, the command is LPR minus capital P and then the printer name, which in this case I'm using Synoptic, and then the file to be printed. You can use LPQ to look at the print queue, and that will give you a list of ID numbers, I guess they're called. And you can delete things from the queue using LPRM. Some older systems will use the command LP instead of LPR. Usually printers can only accept either text or PostScript files, and if you send a GIF file or a JPEG or something, it'll just print out hundreds and hundreds of pages with like one weird character at the top. Linux is smart. It usually pipes them through something that converts them into PostScript, so you probably get lucky and it actually will print the way you want it to. But I have had reams of paper that have gone through with lots of nonsense on them. If you print a file and it doesn't print, please let me know. Printing is just from hell. It tends to go wrong a lot. And what happens is somebody will try to print from one of these machines and it doesn't print, and then they'll try another one. Eventually they'll get it to print, but nobody ever tells me. And then finally somebody will come into my office and be like, oh yeah, I tried to print this file, and I'll go look at the queue and it's got like 400 jobs in it from like 2 years ago. And it's like, if somebody would have told me, I could have fixed this 2 years ago. So anyways, there are ways of dealing with it. I'm not going to get into exactly how to do those, but if you're trying to print and it's not printing, let me know if it's in here. Obviously, if you're engineering or something, I can't help you with that. Printers on this floor. There's other printers in the building as well, but up here, there's a black and white printer called GPN, which is back there. There's a color printer in the back of this room called Prism. It's also back there. The Prism is the one closer to us. GPN is the back one. I generally recommend only print to those if you're working in here, because if you're elsewhere in the building and you print to those, there's a class going on in here, it's awkward. You probably don't want to walk in while they're teaching in here. But if you're in here in a class, that's what they're here for. Otherwise, there's a printer called Synoptic, which is a black and white printer in the conference room next to my office. So if you need to print something, you can usually print it in there. Sometimes there's committee meetings or whatever that are in there. We talked about, we might be moving those into the alumni lounge, which is across the hall here, to make it less obnoxious. There's a color printer called Chroma. Chroma is in 1443. So there's a color printer named Chroma, black and white printer named Synoptic that are in 1443 next to my office. I'm not going to go through these, but you can compress files to save disk space. Basically, it gets rid of redundancy. When you uncompress them, you get the original file back. Moving files from one machine to another. In the early days of the internet, if you can believe this, before it was like commercial, it was like only government and education institutions, and all of the data that went across the internet was in clear text, including passwords and usernames and everything. And nobody cared because the bad guys weren't on it, but they are now. So you don't want to be sending stuff through on clear text. FTP sends things through clear text. FTP stands for File Transfer Protocol. It's for moving files from one machine to another, but everything is unencrypted, including the passwords. The only thing you'd ever use FTP for now is sometimes people make files available on what are called anonymous FTP servers, and you don't actually have a real username. You log in with the username anonymous, and you type in your email, or you can type in anything, it doesn't matter, for a password. It'll let you log in and you can grab stuff from the server. So this is a syntax of how you would typically do that. A better way is secure copy, SCP. That works from the command line on Mac or Linux, and there are tools available for Windows that will run that also. Basically, the password and all the data as you're moving the files from one machine to another are all encrypted. So it's not just going across the text anymore. The command line SCP tool is SCP, and the syntax is what you want to copy it from, and then what you want to copy it to. So you can copy either from this machine to another machine, or you can copy it from another machine to this machine. In this case, I'm going to SCP a file in this directory called file name to some username at a remote machine, so that'd be like poker@cat3.aos.was.edu, colon, and then an absolute path to the file name, or if you don't put a leading slash in front of it, it's relative to your home directory. So if you just give it a file name, it'll just, or don't even give it a name, it'll just put it in your home directory. Going the other way, if you want to SCP a file from some remote machine to your current one, SCP your username at the remote machine, colon, and then the path to the file name, and then a dot, which means it puts it in this current directory, or you can put it in some other directory by specifying a directory. You can use wildcards, but you have to be careful whether it's expanding the wildcard on this machine or the other machine. So in this case, it's copying star.txt on this machine, I think, to the other machine. If you want to go the other way, if you wanted to copy like username at remote star.txt, it has to be in quotes, otherwise it expands the star locally rather than on the other machine. Does that make sense? SFTP, some people prefer the FTP syntax. So SFTP is a program that looks like FTP, but it's actually running SCP under the hood, and all the same commands that you would normally use, put and get, stuff like that, with FTP work, but using SCP as the transfer thing. There are SFTP clients for Windows. There's something called WinSCP. You can get secure FX from software.wisc.edu. There's also FileZilla, I think it's called, that some people use, that does SCP. Okay, that's pretty much what I'm going to say about files. One slide about directories. The mkdir command will make a new directory. mv will move or rename a directory similar to a file. ls will list the contents of a directory, so if you ls on a directory, it will show you the files and directories that are in that directory. Copy will copy a directory, so if you cp -r directory 1 to directory 2, it will it'll copy all the files and directories from file 1 into file 2. If it doesn't exist, into dir2. Is that right? I think if directory 2 doesn't exist, it'll create a directory called directory 2 and copy all the files from directory 1 into it. If directory 2 did exist, it makes a directory in there called directory 1 and copies all the files into directory 1 in directory 2. I think that's what that was. Deleting directories, there's a rmdir for removing a directory, but that only works if the directory is empty. You can also use the recursive remove command, so rm space -r will recursively remove directory and any files underneath it. So rmdir will get rid of a directory, but it'll complain if it's not empty. rm-r will just happily get rid of the whole thing. And then we talked about pwd already. That tells you the absolute path name to whatever directory you're currently in. Environment variables. So we talked about path a little bit earlier in terms of where the operating system looks for executable files. The typical syntax is $sign and then all capitals. So if you want to look at the value of an environment variable, we echo $sign and then that variable name. In the C shell or TC shell, to set an environment variable, a set env, usually they're in all caps, and then some whatever you want it to be set to. In the bourne shell, it's var equals the variable name equals something, semicolon, export that variable name. In bash, K shell, and ZSH, you can do that all in one thing. So you say export variable equals some value. So this thing and this thing are equivalent, dependent for the C shell and the bash. If you just type env, it will print out all of your environment variables. So you can see what environment variables are set in your environment right now. Here's some common ones. $sign capital display will show you what your display is, and if you SSH into a machine and tunnel the X Windows traffic, that will come back as like localhost :10 or some number usually greater than 10. If you're on a machine like in here logged in, it would say like the machine name :0. Like I think this machine is called tranny, so your display would be tranny :0. In the olden days, you would set that to run programs on one machine and have a display on yours, but usually that kind of gets done automatically through SSH. Editor is an environment variable that specifies your default text editor. If you just run something that spawns a text editor, it'll use whatever one you've got set there. Pager is the default pager, so if the default pager is more and you prefer less, in your startup file you can set your pager environment variable to less, and it'll use that whenever you default use a pager. Path is where it looks for programs. Printer you can set for a default printer, so if you do LPR, a file name, and don't give it a printer name, it'll go to that printer, whatever it's set to. Shell is an environment variable that specifies the name of the shell you're using, so it'd be /bin/tcsh or /bin/bash probably. Term has to do with the type of terminal you're using. Usually it's like VT100 or Xterm or something. TZ is what time zone you're in. Other ones you might run into, a lot of times the netcdf variable is used to tell other programs where to find the netcdf libraries. Netcdf is like a data storage format that we use in circumstantial sciences a lot. Load library path is where programs will look for shared libraries if they're not in a normal place, which is like user lib or user local lib. Sometimes they're like stored in different places and you can specify that there. There might be a MATLAB path where it talks about a path for MATLAB files. If you're using on-card graphics or NCL, this might tell the operating system where that is so it knows where to look for map files and other stuff. There are also these things called shell variables, which are like environment variables, but they're not environment variables. They're specific to the shell. They're usually lowercase, but you also get at them with a $sign. In the TC shell, it would be set, whatever the variable name is, equal to whatever you want to set it to. In TC shell, there's a difference between string variables and numeric variables. So if you set a variable equal to 5, it's going to be set to the character 5, not the number 5, so you can't do math on it. If you want to do math on it, you have to set it with an @ sign. So like @I = 5 would set I equal to the integer value 5 rather than the character string 5. And then you can do things like, then you can do numeric operations. So a lot of times I'll do that. If I want to say, okay, try this, if it fails, wait 10 seconds and try it again. But I only want to do that 60 times. If I do it 60 times and it's failed, it's not going to happen and just move on to the next thing. So I can say @I = 0, try something. If it fails, sleep for a certain amount of time, increment I, go back and do it again. So now I is 1, I is 2. And at the end of that, I have a thing that says if I is greater than 60, exit or move on or whatever. So that can be handy. bash, it's set var myvar, so it's kind of opposite of with the environment variables. In the TC shell, you don't use an equal sign. In the bash, you do. With these, with shell variables, in TC shell, you do use an equal sign, and in bash, you don't, which is, I don't know why, who thought of that, but that's how it works. And if you type set, it should print out all of the shell variables that you have set. Okay, startup files. When you first log in, a lot of stuff gets set, like your path, any aliases that you want to have happen every time, how your prompt looks. There's a whole bunch of stuff that you can set in there. Depending on which shell you're using, that name will be different. So if it's C shell, it'll be .cshrc. They all end in .rc usually. TCSHRC would be used for the TC shell, although it will also look for .cshrc because it's used to be C shell, or was written to be compatible. So if you don't have a .tcshrc, you do have a .cshrc, we'll use that. There's a program called, or a file called .login. There's a difference between whether a shell is a login shell or whether it's just running as a shell. It has to do with, like if something's running in the background and someone's not expected to be at the keyboard typing, like a script is running in the background. You would usually use CSHRC to set things that matter for that kind of a thing. But if you're setting things that matter, if you're actually logging into it, like changing the backspace key or things like that, that you probably want to put in .login, because that, if you're in a login shell, it runs .cshrc or tcshrc and .login. If it's not a login shell, it just does .tcshrc and not the .login. Kind of a weird little difference there. There's a .profile, which is executed for Born or the K shell. For bash, it's .bashrc or .bash_profile, and typically it ends up using that one here. For ZSH, it would probably be .cshrc, that kind of thing. Usually files that get run at the start of a program, I used to use an email program called Elm a long time ago, and it had a program called .elmrc, which was the startup files, how you set things for that. There are other programs that you'll see .something_rc, and that's typically settings that get run when you start whatever program it happens to be. Here's an example of what that might look like. So this is an example of a .cshrc file. TCSH are both the same. This says what operating system am I running. If I'm running an SGI, do the SGI stuff. If I'm running Solaris, do that stuff. If I'm running Linux, then do Linux stuff. Here I'm setting that UMask that I talked about, where what are my default file permissions going to be. This limits, if you're running a program and it crashes, a lot of times it will dump an image of itself out in a file that you can use to debug it. It has like all of the variables and like all of the memory image of the program. But they can be big and they can fill up your disk pretty easily. So if you type limit core dump size equals 0, then it doesn't allow them to dump cores, which if you're not debugging, they're not really of any use to you anyways. Then I set a path, which has a bunch of stuff in it. That sets that path environment variable. I set my environment variable for in-car graphics. This is for grads. Here's some stuff for Genpack. I do a couple of aliases here. So I can type H and then run the history command. This will set my prompt to be, I think that's the name of the machine, and then a %, the number of the command, and $sign, and then I exit out. So your startup file is going to look something like that. And you can look at the startup file. On your Mac, it'll probably be .bashrc or .bashprofile, or like it's the .zshrc. If you're running ZSH. In here, it's going to be you're going to have both. You're going to have a .tcshrc, and you're going to have a .bashrc, which I've symbolically linked to .bash_profile. Python stuff lives in .bashrc because it runs usually under bash. And like I said, if you're in here, your default shell is going to be tcsh, but you can type bash at the command line to get a bash prompt, and then you can do Python stuff, and it'll execute that .bashrc thing. Bunch more commands. You can type clear, it'll clear your screen. You can type df, it will show you all of the file systems on the operating system and how much space they have and how much they're using, how close to full they are. DU is disk usage. That will tell you in 500 kilobyte block, 512 byte blocks, how much space each file and directory is using. You can use the -K option to turn that into kilobytes, because I think those are more logical than 512 byte blocks. So if you do something like this, DU minus SK, oh, that's not working. I'm putting my finger in front of it. That's dumb. Here, I'm thinking it's not working. Yeah, so if you DU minus SK star and then pipe it into sort minus NR, that's going to show you disk usage in kilobytes for each file and directory sorted by size with the largest first. So the biggest ones will be on top. You know, if your disk is, somebody comes to you and says, hey, you're using too much disk space, you got to delete stuff. This way you can find out how much space it's using. There's another option to the DU command, the -H. So DU minus SH. That will show the sizes in sort of human readable sizes. So instead of in kilobytes, it'll show like 10 GB or 10 MB or whatever. It's not as useful for sorting because it sorts on the number, and so the gigabytes and megabytes don't apply. Just the numbers do. If you do in kilobytes, then the numbers are bigger if it's megabytes versus kilobytes kind of thing. Script is a handy thing. If you want to capture everything you type and any output that comes to the screen into a file, like you're running a program, it's failing and you want to have somebody look at it and try and figure out why it's not working, or you want to capture the output from an assignment to turn in to somebody, you can type script and it'll start a new shell and start capturing everything you type and everything that gets output from what you type into a file, which by default is called TypeScript. There's a -F option of that, so if you say script -F and then a file name, it'll change that and save it to that file name instead of TypeScript. Do all the things you're going to do, and when you're done, type exit, and it'll bounce you back out to the original shell, and there will be a file in your directory with everything you typed and all of the output. That's pretty neat. The source command will run the contents of a file as if you typed them in at the prompt. Usually where I use that is if I make a change to my .tcshrc or .bashrc, and I want it to take effect right away. Usually that stuff gets executed when you log in. But if you want to have it take effect right now, you can say source.tcshrc, and it runs it and makes it apply right now. tar is used for archiving things. A lot of times when you want to back stuff up, or when you get a distribution of software, a lot of times it'll come in a tar file. I'm not going to really get into how to use that, but just know that it's a thing. SSH is what you would use to connect from one machine to another. So SSH, one syntax is SSH, like cat4.aos.was.edu -L and then your username, or you can type just shorter SSH, your username at cat4.aos.was.edu. It'll connect and ask for your password and then log you in. Again, it's either -X if you're on a Linux machine, or -Y if you're coming from a Mac to forward the X Windows traffic, and you have to have an X server running on the machine you're coming from to be able to do that. You can type who or W to see who's logged into the machine. A bunch of other commands. I guess I won't really go through these. Cal is kind of a cool one. It'll show you the calendar month. You can type cal and the year. Type cal and the year you were born. It'll show you the calendar for the year you were born. I'm not sure how far back into the past it goes. I think it goes to 0 at least. Date command will tell you what date it is. That can be handy. Hostname will tell you the name of the machine. OD is something that I've used if I've got a file and I need to look at it, not in ASCII, but in like binary or something like that. You can get at that to look at it in a different representation. Different compilers. Again, I don't know that I really need to go through these. Are on the handout that you have. Perl, Python. You can run a Python file just by saying Python and then the file name, or you can put $! exclamation /bin/Python or whatever at the top of the script, and then you can just run Python file on its own. We typically in our classes use Jupyter notebooks, and we have a Jupyter Hub server here, and we've started using one in the cloud as well. But you can do those individually on your own machine too. If you install Python, you can run Jupyter notebooks or Jupyter Lab on Java C or Java is the Java compiler. Make is a utility that's used for building packages of software. It sort of has instructions in what's called a make file. And usually you run make -f and then whatever the name of the make file is, the default is make file. So if you just type make, it'll use make file as the default. And it basically has information on how to turn source code into programs. Mail, this is like old school mail. I mean, now you're using a web client, so you never use this, but just so you know they exist. Different ways of text processing in terms of taking text and turning it into formatted text. A lot of people use TeX or LaTeX. There are like recipes here that you basically enter the text and some formatting commands and it comes out looking like a UW thesis is supposed to be formatted, things like that. XPDF or events are programs on these machines to read PDF files. Usually Chrome or Firefox can do it as well. These are a bunch of tools for manipulating images in movies. PBM Plus or NetPBM is a series of conversion programs. ImageMagick is a super useful set of utilities for converting from one image format to another. FFmpeg is a similar kind of thing for movies, like the rooftop camera animations that I do from the images from the rooftop camera. I make those with FFmpeg, or you can convert things from one video format to another. There's all kinds of stuff you can do. In here, there's a program called XV, which is an image viewer, so you can use that to view GIF or JPEG or PNG files. GIMP, I was talking to you about that earlier. It's like Photoshop. VLC is a movie viewer that I use up here for viewing like MP4 files. Xanim is an older animation viewer. I've had issues with it lately, so I wouldn't recommend using that anymore. Web browsing, there's no Internet Explorer or Safari or Edge on Linux. Usually they come with Mozilla Firefox as the default web browser. You can go to Google and install Chrome if you prefer that. There's a couple of really useful text-based web browsers you can install. One of them is called Lynx, Lynx. The other one is called Lynx, Links. Those are useful if you want to like download a file and you don't want to fire up Chrome to do it. You can just do it from a text window. Or if you want to see what a web page is going to look like through a screen reader for like accessibility, that can be useful because it doesn't have any image stuff on it. It's just all using all like the alt tags and stuff like that. So if you want to see what your or a website looks through a screen reader for accessibility, they can be useful. Weather is a program that we use to get at text weather data. GEMPAG is a whole series of programs for graphical plotting and analysis. AWIPS is the National Weather Service replacement for GEMPAG. I have it running in the Alumni Lounge. We can run it in here. It hasn't been incorporated in our classes yet, so I don't typically use it in here. But we can. It seems to be aimed more at forecasters and like creating warnings and stuff like that, but it can be used for like viewing weather data as well. MACIDIS stands for Man Computer Interactive Data Acquisition System Analysis, something like that. The C is small because the computer is supposed to be less than human. That's been around 50-ish years. That's an SSCC product and they still develop it for plotting satellite data, radar data, model data. Overlaying things over satellite data was how it was originally used. GRADS is another plotting utility that's in here. Vis5D, if you've ever come to WeatherWatch, you see John Martin uses Vis5D a lot. It's a really cool way of dissecting a data set in 3 dimensions. I actually have someone's CAT scan from years and years ago. It's called head.v5d, and you can like do cross sections through some guy's CAT scan. You couldn't do that today. HIPAA wouldn't let you, but it's an old software tool that hasn't been developed in maybe 20 years. But in terms of like, gee, I wonder what a cross section looks like here. Boom, there it is. It's really quick and really useful. IDV is another tool that Unidata has created that does similar kinds of, they're all just different ways of creating analyses from data sets. I do have a sample GEMPAG script if you want to get an example of what one looks like. You can copy this /research/sample_GEMPAG_script.csh to your home directory. chmod a+x, so that it's executable of that file, / that file, and it will create a map of the 850 millibar potential temperature and sea level pressure over the North Pacific from today's GFS data. And then you can modify that to look at other data sets or other variables or other locations or whatever. Just a sample GenPack script. And I tested it today and it does work. If you want to run Python, that usually gets installed in your home directory so that you have access. You don't have to have administrative access to modify it. You can get it from here. There are these things called environments. Usually what I'll do is I'll install Miniconda, which is a distribution of Python, and I'll use the base environment only to create other environments for different tasks. Because if you start installing everything in the base environment, at some point you're going to run into a dependency issue where some package you want requires this version, and then another package needs this version. This thing's no longer supported. Then you got to start over, and it's a gigantic pain. So you can create multiple different environments for different tasks that only have the pieces that you need in them. And another way that I use environments is if I create an environment and I've got a script and it's working, and there's updates to the packages, there's newer versions of MapPy or NumPy or whatever, I'll create another environment and test it with the new stuff, because sometimes things break. Python it's free and you can do a lot of stuff, but it's also very dynamic and things change. Sometimes variable types change, or the order of arguments will change, or whatever. And it's nice to have the original environment untouched so things still work, and then you can kind of figure out why they don't work in the new environment. So this is sort of how you would use Anaconda Python to create a new environment. Once you've created an environment, in this case named AOSS 330, you would activate it by typing conda activate that environment. Your prompt will change so it shows you what environment you're in. Got to be running bash to use that, and when you're done with that environment, you can say conda deactivate to take you back out to the base environment. That's more if you want to install it on your own machine. It's already installed in here, and generally in here we use it in the Jupyter Hub, which you access with a web browser, and everybody's got access to certain environments that are already set up. This is a page that explains more about that. If you're interested in installing Python on your own machine, this talks about why I recommend Anaconda or Miniconda, how to get it, how to install it, how to create environments, things to watch out for, stuff like that. So that can be helpful if you do want to install it on your own, or like I said, it installs in your home directory. So like later on, if you end up working on somebody's research server, you can install it in your home directory on their server. You don't need permission. You can just, it goes in your home directory, so you can just do whatever. So that's a useful thing. I think that's it on the Unix stuff that I was talking about. If you have any questions, or if you have things that you've done and you're like, why does this not work, or why does this work, or whatever, I'm happy to answer them. A lot of what I talked about came from a document called Unix is a 4-letter word and VI is a 2-letter abbreviation, which sort of makes sense. There's also something called Unix Help for Users. I have a web page which the 1990s called, they want their web page back. It looks like a 1990s web page, but it has links to HTML tutorials, Unix tutorials, VI tutorials, Fortran tutorials, all kinds of stuff. So, any questions about what I've said? It's a fire hose of information, and we had no break, and it's way past 9 o'clock, and I'm sorry, but any questions, anything you can think of? And I'm happy to stay and go over VI if you're interested, and if you don't, that's fine too.
I have a quick question just about, so when you're talking about your environment,
Mm-hmm.
is that just kind of your home, essentially? Or I guess I'm trying to conceptualize.
So let's think of it in terms of your home. Okay, you have, let's say you're in an apartment, and when you log in, you walk through the front door, and you're in your living room. That's your home directory, is your living room. Your environment is sort of like what you put on the wall. Like somebody might have, maybe there's a window over here, and everybody's apartment has a window over here. That might be like your path. Everybody's got a path set. Maybe you've got a picture of cats being cute up on the wall, and that might be an alias that you did. Maybe you've got, I don't know, how you
Yeah,
maybe
yeah.
you've got a green couch and somebody else has a purple couch and whatever. I mean, that's, your environment sort of customizes things.
Okay.
Variables like where the printer would be by default, where you look for programs, aliases that you have, how your prompt looks, whether your ls command shows things in color or not, those sorts of things. You can sort of customize how things behave to a certain degree.
Okay. So
That's
when
what
you were, I guess I was thinking about it when you were talking about the mini conda and the anaconda for Python. You were talking about creating multiple different environments, and so it's kind of setting up like basically different, like designing a one setup that works for one project versus one that works better for another.
So it's unfortunate that the word environment is used there because environment variables are not the same thing as conda environments.
Okay.
Okay, environment variables are more, I mean, in a sense they are, but not really. The environment that I'm talking about and with environment variables are more like the pictures and things that you set up. Conda environments are like sandboxes almost, where you've got a different sandbox, and this sandbox you're building towers, and in this sandbox you've got a worm farm going on, which we didn't know as a kid.
Okay.
But I mean, you know, that sort of
so
thing.
they're different kind
Isolated
of
versions that,
okay.
yeah, because with Python, when you install it, it has a bunch of stuff installed by default, but usually
Yes.
NumPy is not in there.
Yes.
Matplotlib is not
Yes.
always there. SciPy, Xarray, all those things you have to add later. One example is there's a, not SatPy, there's a radar tool that Kelvin wrote. And SharpPy. SharpPy kind of at least years ago when I installed it, it needed its own environment. Because if you tried to install it alongside other stuff, it needed very specific versions of things that it couldn't get if you tried to put it alongside.
Okay.
So I have a separate sandbox environment for SharpPy, which is completely separate from a sandbox for, you know, making GFS maps, which is completely separate from doing this climate analysis, which needs some climate package that some guy in
they're
England
just
wrote.
designed for different
Right.
uses.
Different sort of tasks, or like I said, different versions. You know, if an update of something comes out, you can create another environment that has the same stuff in it, but newer versions of it.
Okay.
Sometimes the code that you're running breaks. It won't run with the new stuff because they change this variable from a string to a, you know, ASCII or whatever. And it's goofy stuff.
Yeah.
That, you know, and then if you've got the two different environments, you can still run it and it works in the old one. You can actually have different environments use different versions of Python. You know, Python 3.8, or in the days when we were migrating from Python 2 to Python 3, there were big major differences, and a lot of changes had to be made from code that worked in Python 2.7 was the latest 2 into 3. Like the print command used to be a command. It used to say print. I can't even remember how it goes, but there was a major change in how you used it, and it required a lot of recoding yourself. And so, you know, you couldn't just take your Python 2 program, drop it in a Python 3 environment, and it would work. It wouldn't if there were issues. So you could have a Python 2 environment and a Python 3 environment. The stuff works in Python 2, and then you can figure out why it doesn't work and eventually get it to work in Python 3. And they're both next to each other.
Okay. That makes more sense, thank you.
Okay. Yes, I'm sorry, those are different.
No, that's okay. That's
Different
why I was
meanings
like,
of
I was like
environment.
trying to
Yeah.
match those two, and I was like,
Right.
they feel different, so I'm
Right.
glad you clarified.
You know, the original environment that I was talking about had to do with customizing how things
Yes.
work in the shell
Yes.
and how you do
Yes.
things. The Python environments are sort of,
Separate.
yeah.
Got it.
So would you like me to go over the VI stuff, or have you had enough for tonight and just look it over in the thing? I'm not going to be disappointed if you want to leave, but I'm happy to stay. I mean, either way, I'll leave it up to you. How about this? I'll start talking about it, and if you're like, nah,
I was gonna say, how different is it from other text editors? Like, I'm trying to think. I used one before that I can't remember the name of, but like, is it very different?
It can be.
It can be.
Here, let's do it. So in VI, there's two different ways that you use the keyboard. Okay, one of them is input mode, which is what you would expect. You type an A, it puts an A in the file. You type a $sign, it puts a $sign in the file. There's also this thing called command mode, where all of the keys do different things, like the K, lowercase k, will move the cursor up one line, or a $sign will put you at the end of the line, or a capital G will put you at the end of the file all the way. So in this command mode, all the commands are used to do things. In input mode, all the keys just input what you'd expect, like you're just typing along and it would type in whatever you're doing. There are certain commands that you use to switch between insert and command mode. To start VI, you just like VI and then a file name. Usually on Unix, it's running actually VIM, which is an improved version. It has additional things that the original VI didn't have. Kind of like TCSH is to CSH, it's like an enhanced version of the original. If you're creating a brand new file name, or if you're creating a brand new file, it's going to open an empty screen with a bunch of tilde characters down the left-hand side. And that just tells you the tilde is where the tildes are the end of the file. So it won't just be an empty screen with a lot of blank lines on it, it'll be an empty screen with no lines on it with a bunch of tildes that are like below the end of the file. Okay. So there's this command mode and the insert mode. When you first start VI, it's in command mode always. When you first start it up, if you start typing, it's not going to put in the characters that you type. There are certain commands, certain characters that put it in insert mode. And when you're in insert mode, it does what you think. You type characters, spaces, whatever, it types them in as you're typing them. When you are in and backspace will delete them, escape is the character you want to hit to get out of insert mode back into command mode. And usually if you hit escape and you are already in command mode, it's either going to beep at you or it's going to flash your screen like you didn't have to do that. You can usually tell someone who's learning VI because they're beeping all the time because they're just hitting escape when they don't need to. But seriously, if you're not sure where you're at, I don't know what's going on, just hit escape a few times and you're in command mode. And it'll beep at you and that's okay. So command mode is where you do everything that isn't done in insert mode, when you just type in one. In command mode, all the keys that would normally insert characters into the file now have different functions. For example, a lowercase h will move the cursor one character to the left. A J, lowercase j, moves the one character down. And these are case sensitive too. A capital J does something different than a lowercase j. Okay, K moves up and L moves to the right. And if you notice, those are, if you know how to type or keyboard, they're all like right there, up, down, left, right, they're all right there. Which is handy once you get used to it. You don't have to move your hands around that much. You don't have to reach for a mouse all the time. A 0 will move the cursor to the beginning of the line that you're on. A $sign will move the cursor to the end of the line that you're on. A capital G will move the cursor to the end of the file, the beginning of the last line of the file. If you give it a number before it, it will move to the beginning of the line of that line of the file. So one capital G moves you to the beginning of the line at the top of the file. If you type 20 capital G, it will move you to the beginning of the 20th line of the file. Control F will, so you hold the control key down and press F. That moves you forward or down one full screen of text. And these are the commands I was saying earlier. If you're using less as a pager, these work in less, the same exact way, up, down. J will move you one line down, just like it does the cursor one line down in VI. So Control F moves forward or down one screen. Control B moves back one full screen, so up one screen. Control D moves down or forward a half of a screen. Control U will move you up, so forward, backward, or full screen, down and up are a half of a screen, up or down. I said this already, but if you try to move somewhere where the VI doesn't want you to move, for example, if you're in the leftmost column and you press an H key to go left, it'll beep at you because you're already as far left as you can go. Same thing if you hit escape when you didn't need to hit escape, it'll beep at you or flash your screen or somehow let you know you didn't have to do that. So that's moving the cursor around the file, getting through the file. To get into insert mode, there's different ways of doing that. So if your cursor is at a certain place in the file and you type I, that'll put you into insert mode with the cursor starting right where you are. So whatever character you're on, if you start typing characters, it's going to push that over. So it's like before where the character that the cursor is sitting on. A capital I will put you in insert mode, but it'll start before the first character of that line. Okay, so let me keep going. A lowercase a will put you in insert mode after the text, after the character that you're on. So with a lowercase I is right before, lowercase a is right after. Capital I will start inserting at the beginning of the line that you're on. A capital A will put text after the end of the line that you're on. Little obnoxious, but that's how those work. A lowercase o, will put you in insert mode and open a new line right below the line that you're on. So it'll start a new line below you. A capital O will do the same thing, but in the line above you, where your cursor is. So any of those things will put you in insert mode. Once you're in insert mode, anything you type will just show up in the screen. Escape gets you out of it, and then you're back in command mode. Move the cursor around, hit one of these things to get into insert mode again. Here's some other things. An X character will delete the character that the cursor is on, so that's like the delete key.
So what if you need to type a word with an X in it?
Get yourself in insert mode, type an X,
Yeah. Oh, and
hit
then
escape, and then X.
I
This
see.
is in command mode.
I see. Okay, I see.
I guess I didn't say we're back in command
Yeah,
mode.
that's okay.
Sorry, we're in command mode. Hit escape. X will delete the character that you're on. DD will delete the whole line that the cursor's on. So if you want to delete this line, DD and it's gone. You can put a number in front of that too. So if you want to delete 4 lines, you can say 4 DD and it'll delete this line and the next 3. Saving and quitting, if you're going to exit out of the editor, :W will save the file. So any changes that you make, don't actually modify the file on disk. When you open VI, remember I was talking earlier about that temp directory where I said things that only are temporary? When you edit a program with or a file with VI, it makes a temporary copy of that in the /temp directory and modifies that. Doesn't actually do anything to the file that you're actually working on until you save it. :W says write out any changes to disk, and then it copies it back to the file, and then your file has been modified.
So can you, while you're working on something, write it
Yep.
so it saves so that you don't
Yep.
delete?
:W, and then you're right back in insert mode. Yep. This is actually sort of a third mode. The VI is actually sitting on top of an old line editor, which was called ED, which all the commands started with a colon like that. It was really obnoxious. I mean, back in the way early days, you were programming on cards or whatever, so when you type a colon, you're actually running one of these old ED commands, and when you type a colon, it'll show up on the very bottom line of the screen. Type W and then enter, and then it'll do whatever, it'll write the file out and save it. But it'll leave you in the editor. You can still keep working on it, and yeah, you can save it every other line. Very good idea to save it. :WQ will write to disk and exit. And in that case, it will write the file to disk and change the modification type to it, whether you've made any changes to it or not. So if you open a file, don't do anything, :WQ, it's going to save the file. Even though you haven't made any changes to it, it's going to save it back out. And if you look at the file, it'll have been changed right now rather than whenever it was last. And then exit VI. You can type 2 capital Z's in a row. It will write it out if you've changed anything. If you haven't changed anything, it will just abandon the changes and exit VI, and the modification time on the file will be what it was before. It doesn't actually save anything because you didn't make any changes. And if you haven't typed :W, If you get in and you're messing around and you're like, oh man, I broke this file, it's really messed up, I wish I could go back to how it was. If you haven't written it out yet, you can type :Q exclamation point and it will quit without saving any changes. It'll just abandon everything. So, I mean, especially when you're first learning how to use VI, if you get in there and you're like, oh man, I really messed this thing up. If you haven't saved it, type Control or :Q exclamation and it'll get you out without making any changes to the original file. So, okay, I think I talked about this earlier. You can put a number sign in front of DD and it'll delete that many lines from the line that the cursor is on. They're actually not deleted, I mean they are, but they're actually saved in a buffer too. So you can get them back later. So like if you've got 4 lines of text near the top of the file and you want to get rid of them and put them at the bottom of the file, you can delete them from there, move to the bottom of the file, and then use the command to put them from the buffer back up. And I'll show you that in a minute. YY is like DD, except it copies the lines instead of deleting them. So it puts them in that buffer, but it doesn't actually delete them from where you took them from. So you could say 4YY, that's going to copy 4 lines of text into this imaginary buffer. The way that you put them there is with a P, lowercase p. We'll put the command, so if you move the cursor, go to a certain line, 4YY or 4DD, it grabs 4 lines of text and saves them into this buffer. Move the cursor to where you want to put them. If you type a lowercase p, it'll put those 4 lines starting below the line where your cursor is. So whatever line you're on, they're going to show up right below it. If you use a capital P, it does it above, so right above the line that you're on. Okay, this is for VIM, which basically all Linux systems use this VIM newer version. You still call it VI, it runs the same thing, but you can invisibly mark up to 26 locations in a file. It doesn't actually modify the file, it kind of just puts a marker there. So like, let's say you're working near the top of the file and you're like, gee, I wonder what this line looks like near the bottom, but I want to come back to where I am. You can mark this line like with an A, lowercase a, that's why there's 26, it's with a letter. You can do that with an M. So if I'm on a line and I type MA, it marks that line with this invisible marker A. You won't see it anywhere in the file, it's just, you have to remember it. You can move around elsewhere in the file. If you type 'A, it'll go back to the first, your cursor will end up on the first line of whatever line it was, the first column of whatever line it was you marked with an A. And you can make more than one mark, so you can mark A, B, C. And you can use those things with the delete or yank or put or things like that as well. So if you mark a line with an A, move somewhere else and you say D''A, that means delete to wherever I marked A, and it'll go up or down, whether it's ahead of you or behind. Same with a Y. And you can do, let's see, you can do ranges too. I think I talk about that later. Searching and replacing, if you want to search for some text in the file, it's a /. So if you type /text, it will search forward through the file until it finds that text and move your cursor there and sort of highlight it. And that's case sensitive. You can make it not case sensitive by typing :IC, I think it is, ignore case. Will make the searches case insensitive. The question mark does the same thing, but searching backwards. So from where you are up towards the top of the file rather than going forwards. You can type a lowercase, if you're searching for something and you want to find the next one, you can type a lowercase n. See, these are all in command mode. Remember I said all the keys do something, all these are those things that it does differently. So an n will repeat the previous search in the same direction. So if you're searching with a /, you search for some text, you find it. You want to look for the next one, you type n, and you find the next one, n, the next one, n, the next one. Capital N will repeat the same search, but in the other direction. So if you're searching forwards and you type a capital N, it'll do that same search, but backwards. looking for that thing going up instead of down, or down instead of up if you're searching with a question. Okay, for searching and replacing, if you've got a certain thing and you want to replace it with something else, you can say :s/ and then whatever you want to search for. And you have to be a little careful about that because some characters are special characters, like a slash is used in the syntax, so you would need to put a backslash in front of it to mean actually a slash rather than the syntax, or a star, or sometimes a dot, which means any character, that kind of thing. :s/ whatever you want to search for, / whatever you want to replace that search stuff with, and it doesn't have to be the same length, it could be whatever. And then /g means do every instance on a line. If you leave that late trailing G off, it'll only do the first occurrence on a line. If you want to do every occurrence in the whole file, put the G on there, or every occurrence on a line. If it happens more than once on a line, it'll do all of them with the G on the end. It'll only do the first one that it finds if you leave the G off. I guess that's the next thing. You can specify a range that you want to do that. So by default, it'll only do the first one. If you do this thing here, :s, search string, replace string, it'll find the first occurrence in the file of search string and replace it with the replace string. Either the first one on a line without the G, or all of them on that line with it. But it only does it on one line. It doesn't do the whole file, just the first one that it finds. You can give it a range of line numbers to do instead. So if you want to search from line 32 to line 56 and replace all searches with a replace, it'd be something like this: :32, 36. Substitute is what S I think stands for, / whatever you're searching for, what you want to replace it with, every occurrence on the line. And there's even other ways of doing it. So in this case, a $ means the end of the file. 1 means the first line of the file. So in this case, : dot, comma, $, that means from the current line to the last line in the file. Every time you find this, whatever you're searching for, replace it with this. So you can kind of limit it, like if you only want to do certain sections, or if you want to do the whole file, or whatever. 1, comma, $ would say search and replace from line 1 to the end of the file, or there's a shortcut of a % which means the same thing. So : %s / what you want to search for / what you want to replace it with / G for every occurrence on a line will replace every search in the file with replace in the whole file. Sometimes you mess up. Undo is an amazing thing. I love undo. And VI recursively keeps them. So if you've made 50 changes to the file and you type undo, eventually you get back to what it was. Even if you've saved the file, you can go back and undo stuff and get back to it that way. So you will undo the last command that you did. VIM lets you do that. There's probably a limit on how many you can do, but I don't know what that, I've not
reached it.
I don't think so. Capital U, I've never used that one, but it undoes all of the changes that you've made to the current line since you moved there. It's a little esoteric. I don't know why you use that, but it's a thing. A period is useful because it will repeat the last command that you did. So, like, let's say there's the number sign in a file, like a script file, is a comment, and let's say you want to comment out like 10 lines of code. You can go to the first line and insert a number sign at the beginning and escape. And you can go down a line and hit a period, and it'll insert the number sign, down a line, period, down a line, period, and just repeat the command over and over without having to type insert number sign, escape, insert number sign, just type dot.
Does it remember? So if you, never mind.
There's something else I was going to talk about too. I'm surprised I don't have it in here. Maybe that's it. Yeah, I guess, I mean, the kinds of things that I usually use it for are those search and replaces are really handy. Yanking to a marked line is handy. Like if I know, okay, I got I've got this section of code that I want to copy and modify below. I don't know how many lines it is. I'll just go to the bottom of it, mark it with a thing, move up to the top and say Y apostrophe mark, whatever the letter was that I marked it with. And like I said, you can have multiple marked lines, but they're not labeled or anything. You just have to remember where they are. But it's pretty handy. So the reason VI is nice, A, it's on every Unix machine you're ever going into. B, it's just really, if you're doing a lot of coding, you don't have to be moving your hands around. You can just leave your hands on the keyboard and just do everything. And there's a lot of other things that you can do. This page has a link to a lot of stuff. I think, I guess that's the page I had before. This Unix is a 4-letter word and VI is a 2-letter abbreviation is really pretty useful. It has a lot of what I talked about with Unix in terms of files and directories and file system and how to do stuff. It also, I think, talks a lot about VI even beyond what I've done here. And there's other tutorials out there too if you start using it, you want to learn more about how to use it. So, and then there's the externals thing. I think that's it. Yeah, so thanks for coming. Again, if you have any questions, or if you're doing something and something's not working, or something is working and you're like, why does this work? Why do I do it this way? Stop on